Welcome to Exam Readiness, AWS Certified Solution Architect at Associate level. I'm your instructor for the day. My name is Frank Zhang. So I think we can go ahead and get this session started. So here are the things. I just want you guys to be aware. During the whole session, I will be watching the questions panel closely. So if you guys have any technical issues in accessing the webinar, like you lost the screen, the screen is freezing there, or you cannot hear my voice, please just click on raise your hands or maybe put something in the questions panel. I'll making sure I come back and fix the issues for you guys. Okay. So let's get started. So here are the things. We have this webinar. It's gonna be a 3-hour something webinar. I'm guessing we are going to enter this session sometime around 12:30-ish. So it's a long session for a webinar. So in order to have a good user experiences, I'm going to give you guys some break. So we are going to have 2 coffee break during the whole session. So don't worry about this one. You'll not have to sitting here for 3 hours straight. So we're going to have 2 coffee break throughout the session, like every 1 hour something. Every 1 hour and 20 minutes ish, going to have a break. Okay. The other thing I want you guys to be aware is because this workshop is complimentary. So I think we can go ahead and get started. So let's look at the agenda. What are we going to learn? Just a little bit disclaimer. So this is the webinar that I'm going to prepare you. Say, how do you prepare for the exams? I'm going to point you guys into the right direction. Say, if I want to prepare for the exam and get success in the exams, what should I do? What does the exam look like? It's not a replacement for the 3 days course we have. We do have a 3 days instructor-led course. It's called Architecting on AWS. It is highly recommended that you guys went to that 3 days course before you go to the exams. So I'm just gonna pause here a little bit, have a quick poll. Say how many people of you have already attended 3 days course. I just want to better understand my audience. If you have been there, could you please raise your hands for me? Thanks, Michael. Do we only have 1 student that have been to the 3 days class? I will give you guys another second. Say how many of you already attended the 3 days course we have for architecting on AWS? Okay, 2 more hands. Sounds good. And I think that's about it. Okay, thank you guys. So look like we don't have many people being to the 3 days course. In that case, I would say you definitely need to do a little bit preparation for the exams. And for those who didn't raise your hands, how many of you have been doing something on AWS for maybe half a year, 1 year, 2 years? Anyone have been doing something like that? As a architect, raise your hands. Again, we have a couple of hands in here. Okay, awesome. Cool. So here are the things. Like I said, this course won't be a replacement for the whole entire course. We have 3 days. It won't be feasible for me to do that. And also, it won't be a replacement for some hands-on experiences you should already have building your app in AWS Cloud. So what I'm going to do is, because in view that we don't have many people that have many rich AWS experiences, we don't have many people coming to the 3 days course. When we go through today's webinar, I'm going to elaborate a little bit more on the content, on the services, some key features of those services and some key use case of those key features throughout the session. But like I said, this is only a half-day session. We wouldn't be able to cover the whole thing. So instead, what we're going to do in today's session is we're going to look at the exams, talk a little bit about exams so you know what you're going to run into when you actually take that test. And also, we are going to dive deep into the 5 domains that you guys are going to be tested in our exams. So you need to have a very good domain knowledge before you go to exams. Namely, we have 5 domains for the exams: design resilient architecture, define highly performant architectures, how do you protect application and protect your data in the cloud environment, how do I do security, something like this one. And domain 4 is how do I save money while building your app, making cost awareness kind of decisions. Domain 5, how do I ensure you have operational excellence in the cloud? So when you provision, when you build your application in the cloud, making sure it's easier to do, is consistent across different time. It's also like having visibility into what's going on in your cloud architecture. So I'm not sure you guys familiar with this one. We actually has a framework. It's called well-architected framework. Any one of you ever heard of this framework? So here the thing is basically AWS well-architected framework will give you a set of best principles, design principle and best practices in all those 5 different pillars. So say you want to build an app in the cloud environment and get things right in the very beginning, making very good decision at the beginning, that's the design principle you should follow. Okay. It will also give you a set of questions that can help you to evaluate. Say you have your application built in the cloud environment already. Are they following the best practice? Are they doing the right thing? Are you asking a set of long list of questions? Say, are we doing the resilience right? Are we using multiple availability zones? Are we replicate our data across AZs? Are we enable monitoring to have insight into the cloud architect? Just ensure that whenever there's a failure, there's an issue, you will be notified. Something like this. Okay. So what I'm trying to say is, this exam is actually designed after the AWS well-architected framework. Okay, because of that, you can imagine that it might be a very good resource for you to prepare for the exams. We actually have 5 white papers solely for AWS well-architected framework. Okay, so if you have time, if you haven't been to the 3 days course, you can either go there or maybe you can watch those 5 white papers I just mentioned here. You can search them, and maybe at the end of the session, I can give you guys a link that can point you into the right direction. Okay, so this is about the agenda. So we're going to talk about the exam. We are going to help you guys to develop a strategy in answering those questions in the exams. And also, we are going to dive deep into those 5 domains, making sure that you know the content you need to know, the key service, key features you need to know before you go to exams. Okay, does that sound okay? So, like I mentioned, what we're going to cover in this course, question strategy. So when we read a question in the actual exams, you need to know which keywords you need to looking for. Some keywords will help you to eliminate select a number of options very quickly. Since like, hey, if the question is asking about give me the block services from AWS, block storage, you probably know, hey, I have to choose between EDS and instant storage. I don't have to worry nothing about S3 or maybe Glacier. Or maybe the other question, some other type of keywords will be like the qualifying clause, like most fastest storage platform, the most cost-effective ways, and the easiest way to deploy your app in the cloud, something like this one. Those qualifying keywords will help you to eliminate obvious wrong answers, and also it will help you to restrict correct answers to the selected few options. And also, we are going to look into the content. Okay, like in each domain, what we need to know. And you guys are also going to get to answer some practice questions. I think that's one of the key things you can get out of this session. You got to know, hey, we for each domain, what the questions probably look like, and they'll have a chance to answer the question and see if you are comfortable when you go to the exams and answer a question from that specific domain. Okay. So, like I started with the exam. About the exam itself, what to expect, okay? We're starting with the big why. Why do you want to get AWS certified? So you're coming to this webinar session. Apparently, you understand the benefits. I just want to elaborate a little bit more. The first one, the benefit for individuals. So because AWS has been in the market for a long time and is very successful in delivering cloud computing to our customers, and also we have the AWS certification in the industry for quite a long time with very good reputation. So if you get yourself certified for AWS certification, you definitely support your claims to be an expert in the cloud computing area. Okay, you can also using the certs to differentiate yourself from others and peers because it gives you a objective, measurable demonstration of your competency with AWS platform. Okay, with that kind of differentiation, it definitely opens possibilities. It will lead you to more opportunity. Probably you can working on bigger and newer fancy projects. And then in turn, if you success, you can get some reward. And the other thing is at the end of the exam, if you pass the exam, you will get some digital badges to prove you are a certified AWS professional. Okay, you can use that digital badges in some social media websites and maybe put them into email signature to show off your newly acquired skills. We also have an online community for people who got AWS certified. So you can go to LinkedIn and network with other peers who also get AWS certified, and then you can exchange some ideas about some fancy technology and maybe some ideas about some fancy projects. Okay, that's the benefit for individuals. And the benefit for companies, for employers, it will help you to look for people with certs as a measurable proof and making sure that your team internally have the skills needed to be successful in building application in the cloud environment. And of course, you can show them to your customers, say, I have the qualified expertise in helping your customer to build the app in the cloud. Okay, that's the why part. And then before we dive deep into the content for solution architects at associate level, just want to make sure that we have more than one certification. Actually, today we have a lot of certification available from AWS. We call them, we have role-based kind of certifications facing customer from IT industry, from different backgrounds. So you are a architect, you are a system administrator who are very hands-on, or maybe you are a developer who are very into the coding and you into how to actually build apps, design app in a cloud environment. Whichever the case, we have the certification that is right for you. So we actually divide we have IT role-based kind of certification, put them into architects, operations, or developers roles. We also have 3 different levels, starting with the foundational level, which is Cloud Practitioner Essentials. For the newcomers coming to the cloud, either technical people or non-technical people, this is a good place to get started. And then we have the associate level, basically people with around 1 year of experiences doing AWS stuff. You can come to the associate level certifications for solution architects, system administrators, and developers. Okay, and also we have the professional level kind of certs for solution architects and for DevOps. Okay, we do not have a advanced level, professional level certs for developer yet. We merged the developer and ops path into the DevOps one, but you probably know that it's totally different things. If you are a developer, probably you don't want to say, hey, go to professional one, I have to do professional DevOps. Probably that's not the case. And we don't have the professional certs for developing yet. Okay, so if you want to go after the professional one, DevOps one is your choice. And also we have the specialty kind of certs for advanced networking, for big data, for security, for machine learning, for ISR skills. Highly recommended. Okay, one thing I want to mention here is, like, if you want to go after the associate one, you don't have to take the foundational one as a prerequisite. There is no prerequisite, say, if you want to go with professional, go with specialty, do I have to finish foundational one? Do I have to finish associate level? No, you don't have to do that. So if your ultimate goal is to go after the professional or specialty exams, you have two choices. You can either say, I want to go after the associate level and get my certification, get my confidence, I know how it works, and then I build more experiences on AWS before I go to the professional one. That's totally okay. Or maybe you'll say, hey, I've been doing AWS stuff for 5 years, 3, 6, 4 years. I'm very experienced. I know a lot about AWS. I just want to get certs. You can go directly to the professional one. Okay, but this course will prepare you, like learn how to prepare for the associate level solution architect exams. Okay, so if you get AWS certified, hopefully that's the yes for every one of you. If you do get your AWS certification, the thing is we do ask you to recertify your certs every 3 years. It used to be 2 years. The reason for that is AWS keep adding new services, new features to our platform. We want to make sure that whoever got AWS certified, they can have their skills up to date by recertify your cert you already get. You can do that with a lower price, less money to pay, and answering a fewer number of questions. The other way to recertify yourself is rather than go through the recertification exam for the same certs, you can go to another level. You can increase the certification level. Say, previously you get associate level solution architect certified, say, in a week. And after 2 or 3 years, your cert is about to expire. What you can do is you can say, hey, I can go after the professional one because I think I'm now like more prepared. If you get you like professional certs, you don't have to renew the associate level one. It got automatically renewed. That's what I'm trying to say. So if we divide the exam into 5 different domains, how are the questions, how the scores actually allocated across different domains? So here are the things we have a map for that. As you can see, like 34% of the scores goes to domain 1. Domain 1, by the way, is all about how do I design highly resilient, highly scalable architecture in the cloud using different AWS services. This is a big part of the exams. And then after that, 26% go to domain 3, talking about security. Okay, so if you are not a guy from a security background, you might find this a little bit challenging. But the thing is, it takes like more than 26% of the scores. You definitely want to spend a lot of efforts and time in dive deep into security domain. Okay, and also domain 2, how do I define performance solutions? How do I get the most out of AWS services like EC2, EBS, purpose-built databases to get the best performance for my app? Something like this one, 24%. And then how do I save money in the cloud environment? You don't want to spend too much. Domain 4 is about 10%. Okay, it's not that hard. And operational excellence, because it's not a system operation kind of exams, there aren't a lot of scores in this domain, but still we have 6% of them. The idea is, as a solution architect, very often at the beginning of your project, not only you are the go-to guy who design the architecture for your app, but also you are the technical expertise that can provide some like guidance when people run into some issues. They want to using EC2, they want to using transformation, and things doesn't work out as expected. They are going to come to you say, hey, can you help me out? How do I set up EC2? How do I set up EC? How do I use transformation? Something like this one. So that's why you need to know the hands-on part of the AWS services, how to provision resource, how to make a configuration change, how to monitor. Okay, but as you can see, that's only 60%. So it's relatively easier for you to prepare for that domain. The other thing I want to mention here is when we go to the exams, when we see some questions, you might think, hey, this question actually falls into multiple domains. Probably it's a question regarding like performance solutions, and also it's a question regarding operational excellence. Okay, it's a little bit ambiguous. The rule of thumb is you need to know those kind of pillars. It'll be great. Again, I'm emphasizing here. It'll be great if you like have a chance to really dive deep into the AWS Wheel architecture framework. That will definitely help a lot. Okay, and the exams. On a big day, you decide I'm going to take my chance. I feel very lucky today. I want to take the exams. Okay, you go to the test center. There will be a very friendly staff greeting you. You need to bring 2 formal ID with you. One must be a government issued ID with a photo. The other one could be anything, as long as it has your name. I will just using my credit card or anything like this one. You must empty your pockets, lock your personal stuff before you go to the test center, right? They will give you a locker, you put everything in. You are not allowed to bring in any other stuff to the exam center, okay? And you also need to sign a non-disclosure agreement before taking the test. Basically, what it does is, after the test, you won't review any questions you run into in the exams, okay? So, what the question look like? Here are the things. Do we have any labs for the exams? Do we have any like text? Do I have to draw a architecture diagram in the exams? Good news is no, you don't have to do that. All the questions are designed so far. They are all multiple choice. Okay, with either single selection or multiple selection. And if it's a multiple selection, it will tell you how many correct answers are there gonna be. So making it a little bit easier for you. The other thing I want to mention here is there's no penalty for guessing. There's no negative points. So you might as well say not leaving any question unanswered. If you run into this question which you are not quite sure, like what's the correct answer, make a good guess. Like try to eliminate obvious wrong answers, and then you can make a good guess between 2 potentially right ones. And then you can always come back. Don't dwell on one question for too long, because you have 65 questions to answer. You have 130 minutes for all of them. So it looks like you have 2 minutes for each question, but I will strongly recommend you say, hey, giving each question maybe 1 or 1 minute and a half, so that you have enough time coming back and you can review any question you answered previously. If you are not sure about them, you can mark them for future consideration. This is something happened to me a lot. Say at the beginning of the exam, I run into some question which I really don't have a clue. I can make a guess and mark it, and then go after the other questions in the exams. And maybe I got some hints. I got some other tips by answering other questions. I then can come here, I can have a better insight into the one I'm not quite sure about. So making sure you have time for that. For the associate level exams, I'm sorry, but there won't be any writing implements provided for you. Things like pencil, paper, dry erase boards, nothing like that. So it's something you can get for the professional one, but there's nothing like that for the associate level exams. So you have to read the question on the screen and make answer from there. Okay? Before you submitting the exams, at the last minute, you get a chance to review all the questions. With the question you marked previously, you can identify them very easily. You can go back them very easily. Okay, so this is what those questions probably look like. This is single selection question, very easy. And this is multiple selection question. Will tell you how many correct answers are there gonna be. You also probably run into question like this one, what we call a breakfast question. What do you have for breakfast? And how do you prefer your breakfast cooked? So you can say, hey, this is a type of question. We test your knowledge about how to do things. You need to know the steps in doing certain things. This is also the type of question where we want to test your knowledge about multiple facts rather than just one simple fact about AWS services. So we put your question like this one. So if you want to have your breakfast, how do you want it cooked? Maybe you want to boil the orange juice, fry the bacon, brew the coffee, and boil the eggs. Or probably hey, I need to squeeze the orange juice, etc., etc. Okay, the tips for something like this one is you want to eliminate the obvious wrong answers. Says, hey, I do not want to boil the orange juice. I can get rid of option B. I don't want to barbecue the coffee, so I can get rid of option E. But it's of course a personal preference. If you prefer barbecue coffee, it's totally fine. Okay, so this is at the end of the session. You got to see how many questions you have answered. Do you left anything unanswered? Making sure you get them answered. Okay, and For any question you have flagged previously, you can come back. I can revisit. Okay, this is the general strategy in taking the exams. First one, you want to, when we go to the exams, you want to read both the question and all the answers in full one time through. You do not want to rush to answers. Because when we go to the question, very often it asks you to find the perfect answer. Give me the best way to do something. Give me the most cost-effective way. Give me the easiest way in deploying something. Okay, you see option B, you see option C. This is pretty good, but probably not the best. Okay, hold your temptation and say, I'm going to rush the answers. I want to read through the whole option you have. Strategy 2, you want to be able to identify features mentioned in the answer. Says we are talking about, we want to have the number of IOPS available for your storage. We want to meet the RTU RPU for the backup solutions. Something like that. We will help you to identify what's the key features about the services that are going to be tested. And also something about qualifying keywords. I mentioned this one already. And then lastly, you want to eliminate obvious wrong answers and narrow the selection of possible right answers. This is pretty obvious. Some question strategy you can take. Okay, that's enough for the exam itself. We now come to the domain knowledge. This will be the meat for today's session. Okay. So domain 1 is about design resilient architecture. The outline for this domain will be there are 4 different sections that are going to be tested comprehensively in the exams. First one, choose reliable resilient storage. This is all about understanding what storage services available from AWS and their resilience, disaster recovery kind of characteristics. You need to have a better understanding of all the different storage options and their resilient feature. Section B, how to decouple your application components using AWS services. You need to know which service can facilitate decoupling, meaning reduce direct dependency between different components so that it is easier for you to change one component without changing the other. So that if one component fails, it doesn't seem to like a big thing. Section 3, how do I design a multi-tier architecture? Say you have a web tier, application tier, and data layers. How do I make sure this multiple tier application is highly resilient? What services, what features can I use to improve the resiliency of the multi-tier application? You might think of, hey, I'm going to need auto-scaling group. I need to put in a load balancer, which is cost easy, highly available. I want to enable data replication by enable multi-AZ deployment for my RDS, something like this one. Okay, the last section will be how do I design highly available and or fault-tolerant solutions. Obviously, you need to know the difference between highly available solution and fault-tolerant solution. Make good choices. Let's go to the first section. This is all about storage. Okay. So you want to know when it comes to storage, you have different options, either block storage or file storage or object storage. Okay, for block storage, you need to know the use case for different type of storage. When do I want to use S3 as an object storage? When I want to use EFS as a file storage? When do I want to use EBS or instant storage as a block storage for my app? A typical use case for that. Okay, so this is for instant storage. You should know what instant storage is. It's nothing but a direct attached disk to your EC2 instance. It comes standard, it's free of charge, and it gives you better performance, very low latency. But the bad thing about instant storage is you don't have any resilience feature built in the storage. It's very ephemeral in the sense that if I stop my instance or something went wrong with my EC2 instance, I lose everything in instant storage. So which means if you want to put any valuable data into instant storage, you better have application level durability, application level replication in place to keep your data in case of failure. Okay, table example will be Hadoop cluster, NoSQL database like Cassandra and MongoDB, because they all have some built-in replications across multiple nodes. EBS, on the other hand, is another block storage. It's independent of the EC2. That's a nice thing about EBS. It's also available, highly available inside one AZ. So it is resilient in the sense that it's highly available in one AZ. But on very rare condition, say we lose that AZ, we lose that EBS. So in that case, you want to design resiliency for your EBS storage by creating multiple snapshots of your EBS, and also by doing some application level replication of EBS across AZs. And then you also need to know like the snapshot features of EBS. How it works is always differential incremental kind of snapshots, copy of the data at that point in time. And also the process in creating a snapshot, meaning do I need to stop my application to get a snapshot created? The answer is you don't have to do nothing if you are happy with quite consistent kind of snapshot. You do need to stop the application or at least previous I/O, stop any I/O, flush your data from RAM to disk if you want to have a application consistent snapshots. Okay, something like this one. And where do we fill in the gaps? So the thing is, you need to know all the different block storage available and also all the storage options available from AWS. We actually have a white paper for that. There's AWS storage service overview white paper for that purpose. You compare all the different AWS storage options and their use case and their key features. So it is highly recommended. If you are not kind of a storage guy, it is highly recommended for you to go through the white paper. Okay. The other resource might be you can look into the FAQs for the services like EBS, S3, etc., etc. Okay, I think we can then go to some like practice questions, some questions. So here are the things. It might be easier. Some of the questions might be easier, might be obvious to you, but what I want you guys to do is, before you rush to the answer, when we read the question itself, could you please help me to identify what's the keywords for that question? Okay, so let me look into like the question panel. You can put your answer in there. So the thing is, I got a question asking, will a recording be available for this later? I'm sorry about this one, because this webinar is complimentary, so there won't be any recording, there won't be any material shared after the webinar, okay? So I will highly recommend you pay close attention during the webinar. And thank you, June, thank you, Prabhat, and also Nisha in provide the keywords, participate in the keywords identification. So here are the things, you guys are very right. So we want to have a database, okay? We want to have block storage. But I think the other key feature here is it also have something called backup. So what interests us is, sorry about this one. Oops. I have some issues with my slides. Just give me a sec. Okay, I think the backup feature also very important. Anyhow, it's asking for block storage. So you need to find the cheapest storage option for backup data. So we then have A, B, C, D for options. Which one will you go with? Let's look into all the answers provided. Sec. Sorry about this. Yes, so let's look into all the options we have. A, Glacier is not a block storage, so I can very quickly eliminate option A and option C because both Glacier and S3 are object storage. Then we have to make hard choice between B and D, right? B is like code HTTP, and D is throughput optimized HTTP. They are all EBS volumes. It's perfect for backup data. but we want to go with the cheapest one. In that case, you can imagine cold storage might be a little bit cheaper than the super optimized HDD. So the correct answer is option B. Congratulations, guys. Thank you, Jun. You obviously got the right answer and you know how to eliminate the obvious one. Congratulations. Let's come to the second one. So here is in better way, when we go to the exam, you'll see AWS love to ask you questions about different storage options, either from performance perspective or from redundancy perspective. Okay, this is another one. Again, could you please find me the keywords? So the keywords for this one will be, anyone, any ideas? What's the keywords for this question? We have logs, and it's a lot. Okay, we want to find a storage option processing large quantity of logs. Okay, in that case, we need to have performance, right? We need to have performance, and we need to be able to attach that to that EC2. We then been given different options, either they're all different EBS but different storage volume. Okay. So we can then look into all the stuff. Because it is large quantity of logs, we probably need to have a little bit better performance. And because it is logs coming in sequential, it's not like random read and writes. In that case, we probably don't have to go with SSD because solid state drive tends to be expensive compared with HDD. And also it's perfect for random I/O. It's not like perfect for sequential I/O activity like logs. So we can eliminate in this case the SSDs. And because we want to have performance, a large quantity of logs, we need to go with throughput one. The cold HD wouldn't be able to fast enough. Does that make sense? Okay, so the correct answer is D. Congratulations. Denise, you get a correct answer. And then we come to the next section. Determine how to design decoupling mechanism using AWS services. We want to decouple your application components, meaning we want to reduce direct dependency between those components. The benefit of doing that is if you want to change, or maybe if something bad happened to the other components, it doesn't have to cause cascading failures, bring down everything. For example, say we have a 3-tier kind of application where you have web server taking order requests from customers, passing the order to our dispatcher, which in turn passing the order information to application server to fulfill the order. If I configure those servers in a tightly coupled way, meaning, hey, web server know where the order dispatcher is, order dispatcher know where the application server is. They talk to each other using IP address. They know what programming language it is. They know what storage platform it is. If we have any failure in order or application servers, you are doomed. It will bring down your web server as well. You have cascading failure. The nice thing of decoupling is we put a abstraction between different components so that they are not talking to each other directly. We don't have a direct dependency. In our case here, we put a message queue between the order and order dispatcher. And then whenever users send the order request, we put them into message queue. And then they can forget about it. Order dispatcher come to the message queue. The nice thing of doing something like this one is if you have any failures in downstream application, it wouldn't bring down the whole order web server. You're still able to accept order from you end user. So that's a nice thing about like loose coupling. So for asynchronous kind of application, meaning customer submit a request, it doesn't have to happen immediately. The customer is patient, like it's submit the order in this case. In that case, you can put a message queue to decouple asynchronous workload. If it's asynchronous workload, like web server and application server, you can imagine I can put a load balancer in between, and load balancer will be the one that decouple your synchronous application between web servers and application servers. Okay, and you might also have a logging service, which can help you to track the logs of the web servers and send them to some other data storage. If you think of this one, this is also a decoupling because I'm not having my web servers sending the logs directly to some other data store. using another service, putting in between and exposing through well-defined API and DNS is another way for decoupling. And then you need to know about the load balancer. You want to dive really deep into the load balancer service from AWS. Namely, we have network load balancer, we have application load balancer. You need to know the difference between those two, which one working on layer 4, which one working on layer 7, and what does it mean. And you also need to know like the key feature difference, like application load balancer support URL-based routing. If user request go to different URL, go to different APIs, you can using application load balancer to route the request go to different target groups. It can make difference between different EC2 instances and Docker containers. Versus network load balancer, it made no difference of either request. It's just acting as a TCP/IP proxy. It takes the request as it is and passing them as it is to the backend servers, and then passing the response from backend servers back to end user as it is. Nothing smart being done by network load balancer. Okay. So it's what we talk here is not enough for load balancer. You also want to dive very deep into those services like EC2, load balancer, SQS. Some key feature about those services, you definitely need to know about those. A good place to go is you can read the FAQs for all the services we mentioned in this one. And also there might be some other services we haven't mentioned so far, and which is also very important. Think about all those kind of service components like DynamoDB, the resilience feature about DynamoDB, how highly available or fault tolerance it is, and also like Lambda function, AWS batch, etc., step functions. You need to know about some other service components, which is not listed in this section, but it's also very important in helping you design highly resilient kind of solution. Okay, so I list some resources here. Be aware we do have a AWS Certified Solution Architect Associate Level Study Guide available. There's a book, there's an official study guide for these certs. If you go to amazon.com, you can search for this book. You can get this one for tens of dollars. It will give you all the knowledge needed before you go to exams. So I will highly recommend you for you guys to go there and get this one if you are serious about exams and you are not sure whether you get all the knowledge, you get all the skills needed to pass the exam. Okay, let's then look into some questions. Some questions you might run to when you go to the exams. Be aware this is just sample question. You wouldn't be able to run into exactly the same question, but the question in that domain probably look quite similar. Okay, for this one, it's very easy, so we don't have to find out the keywords. It's asking about service that can facilitate a loose coupling solution. Okay, so we have 5 options in here. Let's go after each one. So what's your answer for this one? So it's B and D actually. Okay, congratulations again. Let's go through all the services. A CloudFormation is a service that can help you to define a template describing the desired state of your whole application infrastructure. And then from that template, you can provision, you can configure everything needed to run your app. Okay, it's not for loop coupling. B, SQS, we mentioned previously, it enabled loose coupling for asynchronous workload. C, CloudTrail, this API recording service that can help you to recording any APIs happen in your AWS account. You can then use that one to say, hey, who at what time did what to my AWS infrastructure, who terminated my EC2, who changed my firewall rules, who changed my Azure bucket policy, something like this one. It's a nice service, but it's not for loose coupling. Load balancer, we mentioned earlier, is for loose coupling for synchronous work application. And EMR is nothing but a fully managed MicroReduce cluster. Okay, you can use EMR to run your Hadoop or Spark or high or peak application for big data workload, but it has nothing to do with loose coupling. Make sense? So the correct answer is B and D. And then we come to the third section. How do we design a multi-tier architecture solution? Before we go to this one, I'm just gonna pause here a little bit, just wondering, does anyone have any questions so far? Are we all good? Anyone have any question? Let me look. Yes, one question. Can we get all the resource lists in one place? The answer is yes. At the end of today's session, we have a slide. We have one-page slides that will give you consolidated information for all the links we mentioned in this course. So yes, we will have a one-page kind of resource for all the links, and also there will be another email sent to you guys with all the links available. So don't worry about this one. You do not have to remember all the links. Can we go to the previous question, please? I will talk about this one. So Cora had asking, say, we need to go to the previous question. Is this the one you're looking for? Okay. So, cool. So this is question. And then we have another question asking, I believe it's about another question previously with EVS. So I got a question say, hey, why was it throughput optimized HTTP rather than throughput provisional LPS? The thing is, when we come into log processing, think about this one. I think you are asking about this question, Philip. So the thing is, when we try to processing large quantity of logs, you have to think about the nature of logs. Okay, with log data coming here, they are coming here very sequential manner. So it's not like doing any random read on writes. All the logs just coming here. You just want to ship all the logs and put them into one place. You don't have to do random read and writes across different data. The thing is with SSD, solid state drives, like provisional IPS or general purpose SSD, and they are very good in terms of performance, but it's mostly for IOPS performance, meaning a large number of smaller I/O happen concurrently, and also by random. You can get very good performance with SSD for that type of workload. Okay, but if it's like very sequential read and writes, like a backup to disk, like video on demand, like a big data analytics, what you want to do is you want to scan a data set from one place and load them into the RAMs and do some aggregation, or maybe in this case for backup, you want to just shipping the log from one place and move them to another place. What matters here is like sequential read and writes. Okay, you can go with HDD, which will give you that ideal performance in terms of megabytes per second. Not very decent IOPS performance, but that's not needed. So it's also very cost effective for that kind of workload. That is why we want to go with throughput optimized HTTP. Provisional IPS EVS volume will be too expensive and not ideal for sequential workload. Okay, hopefully that will answer your question. Awesome. Let's come to the next section. So, how do we design resiliency into a multi-tier kind of architecture? So, in this case, the idea is we have the app tier, we have the web tier, we have the data layer. How do we put a resiliency into the data layer, into application layers? Starting with the data layers, okay? So you have different services that you can leverage. In this case, some customers say, hey, I want to put a lot of data into EFS, which is sort of an elastic file system. It's nothing but a fully managed NAS in a cloud environment that allow you to easily share a large number of files across a number of EC2 instances in the same VPC. That's what it is. Okay, so it's a shared storage. EBS doesn't give you ability to share data across different number of EC2. It's also petabyte scale. It's also elastic capacity, meaning you don't have to provision capacity for EFS. You just put in data in, you add more capacity behind the scenes. It's also it's fully managed, and therefore you don't have nothing to worry about resiliency. It's provided out of box. Okay, it supports NFS version 4 and version 4.1, mainly for Linux-based kind of EC2. And this is what it looks like. This is the architecture for EFS. Making sure understand the resilience feature about EFS. Basically, EFS is fully managed by AWS. It's living in a AWS managed networking environment. And when you put in data into EFS, your data will be replicated across 3 availability zones in our region. It's a highly resilient out of box. Okay, but because it is living in a fully managed AWS networking environment, and your EC2 instances, they live in your VPC, in your subnet. How do we facilitate communication between those two? This is why we have this concept called mount target. You can consider mount target as nothing but a ENI representing EFS service and put them into your VPC. Okay, so basically, when you create a EFS file share, you need to create something called mount target. When you create a mount target, you need to specify which VPC, which subnet I want to put a mount target in. You have to select 3 subnets across AZ where you put EFS mount target. Once you've done that, all the EC2 instances, when they remote mount EFS file system, they will just go with the local mount target. If we lose AZA, if we lose AZB, application EC2 in AZC, they can still access EFS through the mount target in the subnet they have. So that's the reason feature for EFS. And then for S3, you should know that it's highly durable. 11 nines durability is highly available as well. It's highly available across region. Okay, once you put data into S3, we replay data across multiple AZs. You need to know we have different storage classes you can choose for S3, not just standard one. You have infrequent access storage class. You have one zone infrequent access storage class. You have Glacier as a storage class for S3. So you want to know when to use which storage class. Okay, what's the type of workload I want to put into S3 and in different storage class. You want to also understanding the security feature of S3, meaning say, hey, how do I do access control? Something we'll talk about later in the next module in security one. You also want to know like how encryption works. Okay, I want to protect my data in S3. To do that, I want to encrypt any data that has sensitive information. When I do data encryption, you then make a choice: do I do data encryption at rest? Do I do data encryption in transit? If it's data in transit, meaning data transfer between one EC2 to one Azure bucket, it's transferred across the web. I want to use SSL TLS to encrypt the data in transit. Okay. For data at rest, you have different options as let's do server-side encryption of S3. So you put data into S3, S3 will do the encryption for you, but you don't have different choices. Say who are going to provide a data key that's going to be used for data encryption. You don't have option between S3 provide a key, KMS provide a key, customer provide a key. You need to know the difference between different options and pros and cons. Okay. And access control. So how do I control who can access my data in Azure bucket? You have 2 ways to do the job, either using ACLs or using some kind of policy. Okay, here are the things. It is recommended using policies to control who can see your data in bucket policy. It could be either bucket policy or it could be either IAM policy. But they all give you fine-grained control in terms of who can do what, who can access your S3 object, who can delete it, who can change it, etc., etc. Under what conditions you can put a request. The API request has to come from this IP address, has to come within those 2 weeks, has to have a MFA token in the API request. Something like that. You can provide a condition in further protecting your data set. So policies give you that. ACLs doesn't give you nothing like this one. So do not using ACLs unless you have no other choice. ACLs is mainly used when you want to say, I want to temporarily open one object and having everyone from internet accessing them. Then you can do something like this one. Like I said, it is recommended using policy. And then you might have another question, say, hey, we have two policy. When do I go with bucket policy? When do I go with IAM policy, right? The answer for that question will be, if you want to enable cross AWS account access to your data in one bucket, in one AWS account, bucket policy might be easier because you can just put other AWS account number as the principal in the bucket policy. And then you can very easily sharing access to the same bucket across multiple AWS accounts. Okay, so that's something you can use for bucket policy. But if you want to enable a group of people accessing the data in Azure buckets, you might want to go with IAM policy because you can just put that group of number of people into the same IAM group. You can then attach that one IAM policy to that group. You can then batch allocate permission to a group of people. So that's where you want to use IAM policy. Make sense? You also want to know what Glacier is. It also give you 11 nines durability. Another nice thing about Glacier is whenever you put data into Glacier, you have your data encrypted by default. It's not an option. Your data is always encrypted in Glacier. Okay. Within Glacier, we have different concepts called vaults and archives. You can think of vaults as nothing but a container for all your archives. It's like a bucket in S3, right? And archive is like all the files you want to put in there for long-term archive purposes. Okay, it's like object in S3. That's what it is. You put data into Glacier, you can pay very less money for it. It's very cheap. But when you want to get data out, you're going to pay relative expensive cost to get them out. Okay, we either have different retrieval options, either expedited retrieval, standard retrieval, and batch retrieval. You need to know what are those kind of different options, what it means. Okay. And again, where to fill in the gaps? We have FAQs for all the services we mentioned so far. CloudFront, another service we haven't mentioned in this section, something you also want to look into, and some other kind of FAQs. And lastly, how do we design like highly available or fault tolerance kind of solutions? This is a famous saying by Warner Roberts, who is the CTO of Amazon.com. He said, everything fails all the time. So if you think about this one, this is so true. All the applications you run in the cloud environment, either on-premise or in the cloud environment, you're running across, if you run application at very large scale, chances are one component or the other might fail. So if you want your application to survive something like this one, you have to design for failure. At the time you design your architecture, make assumptions, say, hey, what will happen if I lose that component? Can my application survive? So loose coupling is one way to do the job. You want to loose couple rather than tight coupling to avoid any cascading failure. Okay. And the other thing I want to mention here is you need to know the difference between fault tolerance and high availability. So what's the difference between high availability and fault tolerance in the context of AWS? Here are the things. AWS definition of high availability will be, say you build this app, you put enough redundancy in place so that if something bad happens, we lose one component, say we lose RDS database. It is okay, we lose one component, you will detect the failure in near real time, and somehow you have automation procedure in place to recover application. So the thing with high availability is you have redundancy, but when something bad happens, you will lose your app for a period of time. You lose your components for service for a period of time, but you have monitoring service to detect that in time. You have automation procedure to bring the application back online. Okay, so that's what high availability means. Well, fault tolerance says I just have enough redundancy in place so that whenever something bad happens, my end user doesn't even feel a thing. For example, if you're using S3, if you're using DynamoDB, if you're using Kinesis, if you're using SQS, whenever you lose some components behind the scenes, you as a customer, you wouldn't experience anything. If we lose one AZ or two AZs in a region, you wouldn't feel a thing. To make it even better, you don't even experience any performance degradation. We have that many redundancy in place, and also some other mechanism in detect failure and routing traffic to other remaining components without you experiencing any downtime. So that's the difference between those two. You can imagine for torrents, you definitely need to have much more redundancy in place. So making sure you read the AWS Real Architected Framework. We have a white paper for resiliency alone. Before we go to the sample questions, let's look into some questions you guys might have. Okay, probably give a good definition. Say high availability means you have certain nets of availability, 3 nets, 4 nets, etc., 5 nets even. And fault tolerance says the service will be 100% available. Thanks much. That's a very concise definition. Let's then look into the question. So, before you rush to the answers, can anyone help me to identify the keywords for this question? Which feature is asking about, and what's the qualifying clause? Anyone, any ideas? Anyone? What's the keywords? So we want to have cost-efficient, highly available solutions. Thanks much, Lisa. And also Prahat. So it's obviously we have a keywords, cost-efficient, high availability. And I think you also need to say, hey, when one AZ becomes unreachable, that's another keyword. So the condition is if we lose one AZ, you still have high availability. So with that in mind, let's look into other options here. There's a tip for the associate level exams. Whenever you see the options, it says something about put something into single AZ. That's the obvious wrong answer. We can very quickly rule out A and B. Okay, in the associate level exams, whenever you see single AZ, chances are that's the bad answer. We can rule them out. Then we have to make choices between C and D. Which one do you go with? You want to say. So you want to ask yourself, what this question is all about? Is it asking about fault tolerance or is it asking about high availability? Okay, so it's asking about we need to have 4 servers to get job done. Okay, I think we mentioned something about this one. Yes, you need to have 4 instances to meet the performance, and you want to have high availability. If we go with D, it says, hey, we want to go with 8 servers with SG across 2 AZs. Even if we lose one AZ, we still have 4 servers up and running to give you that level of performance. But that's fault tolerance, guys. That's fault tolerance, Nisha. So if you go with option D, you have fault tolerance because even if we lose one AZ, you still have 4 servers to give you the number of instance, it gives you the number of SLA. But that's a little bit too much. We also want to have cost efficient, and I'm happy about high availability. Meaning customer will experience downtime, customer will experience performance degradation, but it's okay. It will bring them back automatically with SG. So the correct answer is actually option C. Make sense? Okay. So if I change the question just a little bit, say at the end of the question, rather than say asking for cost-efficient, high availability solution, I'm saying, hey, what architecture will ensure fault tolerance of the application? Should you lose one AZ? In that case, correct answer will be D because that's about fault tolerance. Make sense? You also need to know CloudFormation. What is CloudFormation? What you can do with CloudFormation? What elements can you define in CloudFormation? I'm just curious, how many of you guys have already using CloudFormation in your daily life, in your daily job? Okay, anyone have been doing that? I have 2 hands, 2 or 3. Okay. So here are the things. When we go to the exams, CloudFormation is a service that can help you to have better resilience, because in case of failure, I can use CloudFormation template to bring up a new CloudFormation stack with all the resources available, with all the configuration done, with all the data restored from S3 to your EC2. So that's a service you can use it for readiness purpose. But also, you need to dive deep into CloudFormation. You need to know like what is resource in CloudFormation template definition, what is parameters, what is mappings, what is condition, and depends on. So you want to dive a little bit deep into CloudFormation. Just have 100 overview of knowing what CloudFormation is not enough. Make sense? You need to also know what is creation policy, what is update policy, what is deletion policy. So dive a little bit deep into CloudFormation. That's how you can make sure you can get all the stuff you need for CloudFormation. Okay, so we have a question for this one. Like I mentioned earlier, this is about CloudFormation. Okay, the keywords for this question, I'll make it easier for you guys. The keywords for this question will be same AMI, different region. Okay, so how do I do that? Like I mentioned earlier, you want to be able to dive deep into CloudFormation, knowing about all the different things you can define in a CloudFormation template. In this case, what I want to do is we want to use one template and creating an application in different regions. Of course, they are going to use, even if the same AMI, it's going to be different AMI ID. The same thing, you copy AMI from one region to the other, you get a different AMI ID. Okay, so the correct answer for this one will be, you can define a mapping and put all the AMI for different region in a mapping table. The mapping is nothing but like a dictionary. It's like a hash map where you keep, say, for US East, I'm going to use this AMI ID. If I'm running this CloudFormation template in Sydney region, it's going to use another AMI ID. That's what it is. So that's why when I say, hey, you need to dive deep into CloudFormation template, knowing what elements are there in the CloudFormation template is very important. Okay. Resources, parameters, mappings, depends on property, creation policy. You need to know what are those things. You also need to know about Lambda function. Okay, at the architect associate level exams, there aren't many questions regarding serverless, but there are a big number of questions regarding Lambda function, Cognito, API gateway, step functions, and also the MVPD. Okay. So making sure you know about those service-based components, their use case, and their key features. Make sense? So for Lambda, you need to know what Lambda is. You can run your code without managing the servers. You'll have high availability, scalability, out of box, something like this one. And it's a pity that in this course, in this webinar, the material I have doesn't list any other serverless components like Lambda. I'm going to put them into the questions. So all the serverless kind of components like Lambda, API gateway, Cognito, okay, and also step functions, DynamoDB. All the services we haven't talked about in this course, in this webinar. Actually, in the slides we have for this webinar, it doesn't talk about nothing about those services. There might be some content about DynamoDB, but anyhow, all the service components, you need to know what they are, what their key features, and the use case for the key features. That will do the job. So making sure you do a little bit kind of a homework for the services I just posted to you guys in the question panels, making sure you're reading the FAQs for those services, understanding their key feature and use case. Make sense? Okay, so we have a question for Lambda. It's actually asking about the how part of Lambda. How do I configure Lambda? In this case, it's about how do I get the print statement from Lambda function. This is know-how. This is if you create a Lambda function before, you should know how it works. If you haven't done so, highly recommend to go to one of the like self-pacing labs and do a lab with Lambda function, have a little bit hands-on experiences with Lambda. Okay, so in this case, the correct answer will be like option C. But let's go through all the different options we have. Option A, connect to Lambda function using SSH and looking at system logs. You wouldn't be able to do so. Okay, there won't be Lambda function doesn't allow any incoming requests going into the Lambda, so that won't be feasible. Okay, you can only send outgoing requests go to other places, grab something back. You cannot initiate traffic from other places and having go into that Lambda function. Not gonna happen. Lambda function writes all output to MS3 by default, which is not the case. It doesn't do that. Okay, and you can then put them into CloudWatch logs. Yes, print statements are ignored in Lambda, which is not the case. Whatever you put into in your Lambda function code, whatever you put in there, say I want to print them, I want to log them, it go to CloudWatch logs. So the correct answer for this one will be CloudWatch logs. Okay, hopefully everyone got a question right. And then last one, the key takeaway for this module. Like I said, single AZ, rule out that's obvious wrong answer. In most cases, prefer AWS managed services rather than build some service by yourself. Say SQS is preferred over setting up a RabbitMQ on HTTP instance, something like this one. Knowing the difference between fault tolerance and high availability, and like having redundancy design in your application, think about what will happen if something went wrong. Okay, so that's the key takeaway for module 1. And because we just have a 1 hour session, 1 hour and 10 minutes, and this is webinar. I know that it's going to be a little bit hard for a webinar session like this one, and keep you focused on the content. So I think how about we stop here, have a little break. How about we have a 15 minutes break? It's not 10:15. Let's come back at 10:30 for the next module. That sound good? Okay. So what I'm going to do is I'm going to say if I can put a timer on the screen. Okay, I will say guys, go out there, stretch your legs, walking around, have some water, have some refreshments, and coming back at 10:30. Okay. We'll come back. We talk about how to make good choices of your storage from performance perspective, and also making good choices of purpose-built databases like either RDS or DynamoDB or some caching service. Okay, so section 2 is about caching. How do I apply patching to application to improve performance and supporting very large-scale kind of application. And section 3 is all about elasticity. That's where we talk about auto-scaling group and all the other fancy features you can scale application. Okay, let's go to the first one. That will be how do we choose storage and databases. So I mentioned this one like once previously in the previous module. AWS love to test your ability in making good choices between different storage platforms. There's another example. You should know the difference between different volume type for EBS, namely SSD and HDD. As you can see, for SSD, the dominant performance attribute for your application will be IOPS. How many I/O operations per second? That's what it matters. For provision IOPS SSD, it gives you up to like I think number is already 64,000. Don't worry about this one because in the exams we do not test any numbers like what's the max IOPS you can get out of one EBS volumes, provisional IOPS EBS volume, something like this one. There won't be any question regarding specific number because that's some kind of a limit. When we improve our services, that limit might be like increase. So that's why we don't test your ability in knowing the numbers. But you should be aware there are certain limitations. You should be aware, say, SSD is perfect for IOPS. sensitive application, and HD are ideal for megabytes per second sensitive application. Okay, and you should know the difference between general purpose SSD and provision IOPS SSD. When to use which one? Okay, general purpose SSD give you better performance, but it's not consistent. You cannot guarantee like 99% of the time you can get ideal performance out of general purpose SSD. Well, with provision IOPS SSD, you get, if you provision how many IOPS you want for the EPS volumes, 99% of the time you can get a desired number of IOPS. So highly persistent, highly consistent performance for you like IO intensive application. Okay, HD are ideal for data warehousing, big data stuff, backup to disk, and video on demand. You should also know how to use an S3. I'm assuming you already know what is Azure bucket, what is an object, how do I get a URL for one object once I put data into Azure bucket. You should also know that, like, what's the access control by default. If I put an object into my bucket, what's the default behavior? Is it denied by default? No one can access the object unless the owner of the object. Okay, and I have a question here. So, I've got a question that says IOPS on its own is meaningless as there is a latency of disk, QoS, and many other factors. That's a very good point. So, the thing is, when we talk about I/O performance, it's not just about IOPS. Very often, we also need to think about like how many requests hitting on disk per second, and how deep that queue is, and what's the expected latency when user perform a I/O request, how long it take for the disk get back to end user. So latency also matters. So you are right about this one. But here the things, we are talking about associate level certs. In these exams, we test you knowledge about different storage options, their volume type, and their use case. We don't dive deep into like what storage performance means, like finding the best balance between IOPS and megabytes per second, latency, and QoS. There is always a trade-off. So if you increase your QoS, you can imagine you increase the latency when people perform I/O when there are a large number of I/O coming in. If you have better IOPS, chances are you have like smaller number of I/O size, and in turn you have a like reduced number of megabytes per second. But that's the thing, for associate level certs, we don't go to that level. Okay, so that's a very good point. It makes sense for sure, but it's just not that like that's not something I'm gonna test in the associate level exams. So don't worry about this one. Okay, cool. Anyone have any other questions? No? Okay, if no question, I will just continue. You have a hand in here. I'm assuming someone have question. Is that you, Nisha? Do you have any question? If you have a question, you can just post them in the questions panel. And if you have any difficulty accessing the webinar as well, put them into the question panel. I will then handle them. For now, I will just keep continuing. But please do let me know if any question or any issues. Okay. So as a storage class, you should know we have standard, infrequent access data, and when to use which one. Okay, and what's the benefit of using S3 standard infrequent access? Namely, you can have you are paying lower cost per gigabyte stored, but there will be higher cost for data accessing. So that's why we say this is S3 standard, but infrequent access. We're actually changing the pricing structure for standard and standard infrequent access. Okay. You also have this ability in setting up a life cycle policy. It says, when I put my data into S3, I can use a policy to automatically move my data to different storage class to save cost and have the persistent SD1 for my data set in Glacier. Okay, something you should be aware of. Then I have a question for this one. I think this will be an easy one. It's a very short question itself, so don't bother finding the keywords, but please give it a try. What's the correct option for this one? It says select two of them. What does S3 object storage differ from block and file storage? Anyone, any ideas? So all objects in S3 are replicated across AZs. That is correct. Okay, and it allows you to store unlimited number of objects, which is also correct. So A is correct, and okay, sorry about this one. A says unlimited number of objects, which is correct. B says objects are immutable in the sense that whenever we want to change a single byte of the object, we have to change the whole thing. We have to replace the object. What it means is with S3 objects, you don't have like efficiency when your app wants to come back here and frequently change the data set. Because even if I want to make a tiny, small, little bit kind of a change, I have to replace the whole object. So C is not correct because we have a storage class for S3 that says it's single AZ deployment. So you have an S3 infrequent access storage class with one AZ deployment. So C, that's why C is not correct. And not to mention, we wouldn't replicate data across regions for obvious data sovereignty issue. So the correct answer are A and B. And I think I got a question from Isha mentioning what's the facts for us to remember from this table regarding different type of EBS forms. Okay, so like I mentioned, you should know like SSD optimized for IOPS kind of application. HDD is optimized for megabytes per second. You need to know what's the typical application, what's the typical workload that's demanding higher number of IOPS. There will be frequently accessed database, frequently accessed kind of file system. The other case for storage, for HDD storage will be like if it's backup to disk, if it's reporting, if it's like video on demand, if it's Hadoop, you will be happy customer of HDD. So you don't have to remember any number in this one, in this table. Just remember which storage volume is perfect for which use case. That will do the job. Okay, so I will then come back to this place. Hopefully that answers your question. We have another question. So features of EBS, select two of them. Again, this is a relatively easy one. And you want to give it a try. So do we automatically replicate data within the AZ? The answer is yes. So A is correct. Okay, we never put in data into EBS. Behind the scenes, we mirror your data into another device. So you have data replicated within the AZ already. EBS data automatically back up to disk. Nothing like that will happen. You have snapshot capability for EBS, and the data goes to S3. Okay, and EBS volume can be encrypted. That is correct. EBS volume. Remember when we go to exam, do not rush to answers. I think A and C are correct, but I need to also look at B. Can be attached to more than one instance in the same AZ. That's not the case. At the moment, you can only attach EBS to one EC2, okay, at any given second. So this is incorrect. That's for storage options. And also, there will be a lot of questions regarding databases, okay? There will be questions go a little bit deeper with databases offering we have in here, namely RDS, DynamoDB, and Redshift, which means you should know the key feature for RDS, you should know the key feature for DynamoDB and Redshift, okay? For RDS, that will be multi-AZ deployment, what that is and what it means to you. For database, different database engine, you have read replica, stuff like this one. For DynamoDB, you should know DynamoDB has features like partition key and sort key, and how to make a good choice of a partition key and sort key. And also, you have secondary index in DynamoDB. We have global second index. We have a local second index for the difference. You also have DynamoDB streams feature. What you can do with DynamoDB streams and how backup works for DynamoDB, because we do have the backup feature and any point in time recovery feature for DynamoDB. Something like this one, and also global table for DynamoDB. For Redshift, I think you'll be happy if you know like it's a petabyte scale kind of data warehouse. You can load data from S3 from DynamoDB into Redshift in parallel. And what's the typical use case for Redshift? That should be okay for Redshift. And you probably know we have other databases services from AWS, like Amazon Neptune, which is a graph database. You should know what's the use case for like graph database, like Amazon Neptune. Okay, and also we have DocumentDB now, which is a MongoDB compatible database service. And also we have the time series kind of database, etc., etc. Okay, so be aware that we have other databases offerings from AWS, what their use cases are. Okay, that will do the job. For the services we list here, you want to delve a little bit deeper, know about the key features. Okay, you all want to also know like when do I go with RDS? Probably when it's not a good case, use case with RDS. Namely, there are some, if you want to have complex transactions or complex queries being done across multiple tables, you want to go with relational one. And the transaction rate is actually medium to high. It's not too much, like going to like tens of like hundreds of thousands, more than that. That won't be scale enough for RDS. Okay, and when it's not a good use case with Amazon RDS, anytime you have transaction larger than 150K, 50K transaction per second, whenever you want to have multiple sharding, whenever your access pattern is relatively simple, not complex transaction, not complex drawing, you want to do simple put and get request to get whatever information that interests you based on some key values. You probably want to go with NoSQL rather than using SQL database. Okay, something like this one. So what I'm saying is you want to know the different use case of the RDS. Okay. So just give me 1 sec. I think we got a question. Hold on a second. I will handle that later. So just give me 1 sec. Sorry about this one. Sorry about this one. I just try to handle some questions privately. And sorry, let's come back. So you need to know for certain database engine from RDS, if you have a very read-heavy kind of application coming here, what you can do is you can enable read-replica. Namely, the database engine like MySQL, PostgreSQL, Aurora, MariaDB, they give you this ability in creating multiple read-replica. You can then offload the read activity to those read-replica across easies. Then you can reduce the workload on your master. The other benefit of read-replica is very often if you want to do some reporting, I want to run some like dashboard, I want to run some reporting at the end of the month. I don't want to do that on my production database because that will cause the contention between transaction happen on my primary database and also reporting workload. So what you can do is you can create a read-replica for reporting purpose. So the thing is you want to know when do I want to use read-replica, like reporting or offload read request. Okay. For DynamoDB, like I mentioned, there are some key features you want to know about DynamoDB. I think I already mentioned them previously, like the partition key. I'm going to put them into the questions panel and send to everyone so that we all have the information. Okay. Hold on a second. yeah, my question panel doesn't work so well. I will try to do that later. But anyhow, all the features I mentioned earlier regarding DynamoDB, you should know about them. And also, you should know DynamoDB has this thing called provision throughput. That's how you make a decision at the time you create a table, say how many read and how many writes per second allowed on the DynamoDB table, right? So with the payload, each read capacity unit give you ability to have a strongly consistent read at 4 kilobytes payload and 2 eventual consistent reads with that capacity. Okay, and what it means when you choose different application. And then let's go to some questions for this section. Ideal use case for RDS. I think we just talked about this one, but anyhow, I will give you guys time to read through the question and make your selection. So ideal use case for RDS. So complex transactions. It's not just simple put and get. So A is correct. It doesn't support sharding well, so you cannot. You don't want to use RDS if you want to sharding a database out. Medium to high query rates. That's correct. And RDS customization. The thing is, RDS is fully managed by AWS. Therefore, you don't have the ability in go out and change some customization of database. Say, go to the operating system and make some configuration change of your database engine. That is not supported from RDS. Okay, so the correct answer for this one will be A and D. Congratulations again. I see most people get it right. How about this one? I'll be very happy if I go to the exam and see question like this, right? So non-relational database, that will be D down DB. Or the other one, A and B are relational one, and C is object storage. Okay, so if you're lucky, you might run into a question like this one, which is very simple. So you can very quickly get a correct answer and move in. Okay, but like I said, there are some complex ones. Say, for example, we have something like this. This is a relatively complex question. So can anyone give me the keywords for this one? Before go to the options, can anyone find me the keywords? What's the keywords for this question? Okay, thank you, Jun and Lisa. So obviously, we talk about relational database. Anyone notice that one? It says a relational database is needed. Okay, and 10 gigabytes incremental every day. And we need to have 4 reader replica to handle the workload. Okay, so that's the kind of requirements. And also, we're talking about 10 gigabytes incremental every day. So how do we handle that? Whenever every day is going to increase like 10 gigabytes. So looking at the option we have, DynamoDB and S3, I can get rid of them very easily, right? Okay, and Redshift is a data warehouse. It doesn't give you reader replica capability. So I can obviously eliminate all the obvious wrong. A and B, non-relational one, okay? And G is a data warehouse, doesn't support reader replica. And then we come to unknown Aurora, okay? So the question is actually testing ability understanding Aurora, being a relational database, and also you don't have to provision storage capacity for Aurora. It gives you like 10 gigabytes incremental capacity whenever needed. So you don't have to provision that. It grows by 10 gig. Okay, and also you have reader replica. You can actually create up to 15 reader replica using Aurora, some for reader offload reader request and some for reporting purpose, making it a perfect database engine for both on OLTP, online transaction, and OLAP, online analytics kind of workload. Okay, so that's the thing. Yes, there is a maximum size limit for Aurora. I believe it's 64 terabytes. Yes, you are quite right about that, Junt. So the thing is, if you don't reach 64 terabytes, you can just keep getting new capacity. from Aurora, having all those incremental. But at the end of the day, if this thing keep going on, say going on for the whole year, you can do the math. Probably you are running out of capacity. Anyhow, that's a very good point. So this question, I agree with you, is not entirely correct because we will hit on the capacity limit. Yes, I agree with you, Jun. The last section, the second section for this module is about applied caching. So how do we apply caching performance? There are two ways to apply caching and boost performance for your app. First one says, hey, if you have some data that is frequently accessed by your end user, and your end user is all around the globe, all around different places, quite dispersed. One way to boost performance is let's bring the content, let's copy the content a little bit closer to end user, so that whenever end user try to access content, they don't have to travel across continent. Okay, this is something you can do with CloudFront. Okay, so you need to know, like CloudFront, the key feature is it supports both static and dynamic content. It can deliver both content to end user around the globe. Okay, you can define origin servers, namely where all the original content being generated and served. You can configure different origin servers like either Azure Bucket, EC2 instance, load balancer, or some web server on-premise. They also give you ability to protect private content. So when you're using content delivery network like CloudFront to deliver your content from Azure Bucket, say, to end user from internet, what you can say is you can say, hey, for all my PDF report, for all my MP4 video files, those are private content. You cannot just come from internet and access my assets. Instead, I'm going to ask you for authentication and authorization information before CloudFront deliver the content to end user. Okay, so what you can do is you can come here and you can define something called caching behavior. Say if the URL from your end user request matching this pattern, say star.mp4, star.pdf, for those kind of content is private. Okay, if you want to access them, you need to use a pre-signed URL and a pre-signed cookie, or a pre-signed cookie in accessing those private content. Okay, in that case, as a AWS customer, you need to create a key pair, which is a public key and a private key combination. Okay, you then provide that public key to AWS to CloudFront. That public key is used for validation of the pre-signed URL. You then have the private key. You hold the private key. You send the private key to your application servers. In your application server, in your code, you authenticate user and authorize user. Say, hey, I know this user Frank coming here. Frank should have access to this PDF document designed for Frank. You can then use the private key you have to create a pre-signed URL for that PDF document. You send the pre-signed URL to Frank. Frank send the pre-signed URL to CloudFront. CloudFront using the public key we have to validate whether it's a good pre-signed URL or whether it's a valid pre-signed cookie before it delivers content to Frank. That makes sense? So that's how we can protect your private content in CloudFront. And then you have to also think about how do I protect my data in Azure Bucket. Say you're using Azure Bucket in hosting all your state content. In that case, you might want to say, hey, what if some people bypass CloudFront and go to my Azure Bucket and get a PDF belong to Frank? In that case, what you want to do, you want to say, I want to make the Azure Bucket private. Here comes the good question. So if your Azure Bucket is private, how do I allow CloudFront from Azure location coming back to the Azure Bucket and get the content? The way you can get job done is you can use Azure Bucket policy, and you can then create a object or origin access identity for that CloudFront distribution. Okay, so there are two things need to be done. First one, create an OAI, origin access identity, for that specific CloudFront distribution. Secondly, put an OAI into Azure Bucket policy says, I will deny any other get audit request from internet and only allow that OAI come to Azure Bucket and get content. Does that make sense? Okay. And there are other security improvements you can get from CloudFront. Namely, we can run AWS Shield Standard and Advanced in protecting your application against DDoS attacks. And you can also implement AWS WAF, AWS Web Application Firewall, and implement the firewall rules in the CloudFront edge location to protect DDoS at layer 7. Okay. So we talked about CloudFront already. So hopefully you know about how CloudFront works. We have CloudFront edge location. We have origin servers, maybe in Azure Bucket, maybe in EC2. You have a user come from global place and come to CloudFront distribution in order to get the content. Okay. And the second way in applied caching will be like, let's put a cache along with my database, in front of my database or in front of my backend services. The idea is whenever you see a lot of requests come to your database and make expensive queries against the same data set, you might get a huge benefit of putting the data set into the in-memory cache so that your request doesn't have to hit on database, make expensive queries, or maybe you don't have to send the request to some third-party service to get the response. You can just cache the content like top 10 books of the website and put them into in-memory cache. And then you can get data back to end user in microseconds. That's magnitude faster than putting data into disk. And also you can reduce the cost of your backend database because you don't have to configure too big a database backend. So here is the fun part. Okay, we have a service called Amazon Elastic Cache, which can help you to run a fully managed cache cluster in the cloud. And then we give you different options. You can choose either memcached as a cache engine and Redis as another type of cache engine. So the key question will be, hey, how do I make the choice? How do I know when to use memcached and when to use Redis? Okay, this is an example. So you need to remember everything on this table. What's the benefit of memcached? Namely multi-threading, easily horizontal scalability, meaning adding nodes, removing nodes horizontally, but without any manual configuration because you have auto discovery library available from memcached. Versus Redis, it supports modern fancy data structures. You have data persistence feature that can help you to persist data from RAMs, put them into disk. You can also put a PubSub model, which is perfect for social application, IoT applications. You can create a replica and having a cluster mode created. Making sure you know about different pros and cons of each cache engine. I heard people even run into some questions regarding some authentication, right? So how do I do authentication on Redis? Something like this one. So this is another question. Say, what are the following objects are good candidates to put them into in-memory cache? We have different options here. So session state is perfect to put into cache. So I agree with this one. Product catalog might be another good choice. So because a lot of people going to website, they want to see the product catalog, and then they can make a choice, and they cannot wait. You want to improve the performance by putting a product catalog into the cache. Shopping carts, that's a tough one, okay? Because you might want to have durability for anything in your shopping cart, but if you put them into in-memory cache, you don't have the durability feature. So I will say ideal data storage for shopping cart will be DynamoDB. Okay, but in this case, I don't have any other better choice because D is bank account balance. You wouldn't want to put a bank account balance in RAMs because you just cannot afford to lose them. So D is obviously incorrect. And then I have no choice because it mentioned you have 3 correct answers. I will say A, B, and C are correct one. That makes sense, okay? But be aware, shopping cart very often you want to have durability, so actually DynamoDB is even better. So it gets performance at very large scale. You also get durability. Okay, congratulations guys, you have it correct answer, both of you. And hope my code Do you agree with what I say? So product catalog is good, but bank account balance, don't want to put them into cash, okay? Because you cannot afford losing them. And I just realized, sorry, I pronounced one of your name incorrectly. It's supposed to be Jonate. Hopefully I get it right this time. If I'm wrong again, sorry about that. Okay, let's moving on. And this is an easy one. Which of the following cache engines are supported by ElasticCache? We just talk about this one. This is easy. I hope when I go to the exam, I run into a question like this one. But chances are there are only going to be 1 or 2 questions like this one in the real exams. Most of the question exams are going to be like use case based. It's not just asking about the feature of a service. Instead, it's going to give you a scenario, give you a use case, and talk about like which service, which feature can you use to solve that problem. Okay. The last section for this module will be elasticity and scaling. Okay. So when it comes to scale, when you have more traffic coming to your website, you might running out of resource in supporting those kind of traffic. In that case, you want to add in more resource, you want to scaling. Okay, so there are 2 ways in adding resource in the cloud environment. First one says vertical scaling. I can just change it to a bigger box. Okay, that is very doable because you are not trapped in one specific configuration of EC2 in the cloud environment. Be aware, when you do vertical scaling, you do need to introduce stop time. You do stop that is to instance, change instance type, and change it to a bigger one. Okay. The downside of vertical scaling is like you have downtime and you have a physical limitation in terms of how far you can go. The pro of vertical scaling is you don't have to, there is no like requirements on your application, right? So it doesn't ask for any application level support. You can just change to a bigger box, change to a bigger box. It usually just works. Another approach will be horizontally scaling. Say, hey, rather than changing to the bigger box one, I'm going to asking for more instances. I'm adding boxes. Whenever it's like too many, let's remove them. So adding and remove instances horizontally, giving you flexibility and ease of implementation, and also there is no downtime. But be aware, it does have some requirements on your application. You cannot just auto scale everything, right? You cannot horizontally scale database, for example. Okay, so you need to know about this service. You want to dive really deep into EC2 auto scaling. I mean, you need to know how it works. The way EC2 auto scaling works is adding instance and terminating instance on your behalf. And you can also have integration between AST and load balancer, so that whenever AST adding a new instance, having it fully bootstrapped, it will register the newly launched EC2 instance to load balancer automatically. So that's some nice thing about them. And whenever AST launching new instance or terminate old ones, they always try to balance the number of EC2 across AZs. Okay, so that's something nice about them. And be aware, this is a little tricky. We do have 2 services, EC2 auto scaling and AWS auto scaling. Okay, AWS auto scaling not only scale EC2 but also can scale some other services like ECS, Elastic Container Service, maybe RDS Aurora, maybe DynamoDB table provision capacity. So you can use AWS scaling to do a lot of things. And when it comes to auto scaling, there are different components. You need to know what is launch configuration, what is auto scaling group, what you can configure, what is auto scaling plan, what is auto scaling strategy. And you need to know like AWS auto scaling versus EC2 auto scaling. What's the difference between them? Namely, you can even do predictive auto scaling with AWS auto scaling service. And EC2 auto scaling only support reactive scaling. You can define your scaling policy, either simple scaling policy, target utilization scaling policy, and step scaling policy. You need to know what the difference between them and which one is recommended. By the way, which is the step scaling policy. because it allows you to respond to changing metrics differently. Say if I see the metrics is 70%, 80%, it is higher than my threshold setting at 60%. I will just add in one instance because it's not a big deal. But if now I see metrics going up to 100%, not only is hot, it's super hot. Adding one instance wouldn't be fast enough. I want to add two instances. This is what step scaling policy means. So in most cases, step scaling policy is recommended because it allows you to respond to the metrics more smartly. Okay, and then you need to know about CloudWatch. You need to know about CloudWatch metrics and CloudWatch alarms. You need to also know what is CloudWatch custom metrics. Okay, and how to create them. And I think most of you guys probably already seen a topology like this one. This is a triad of AWS services having a load balancer. Having a load balancer in front of your EC2 instance, and having ASG manage your EC2 instance and define scaling policy to scaling out, scaling in, default CloudWatch alarms to monitoring the metrics and alert on the metrics and make a scaling decision. So we have a question for this one. Probably you'll find this one a little bit easier. So anyone knows the good answer, correct answer for this question? So remember I talked about if you want to auto scale your EC2 instance, we have a triad of AWS services. Make sense? That will be, anyone have the answer for this one? Yes, that will be C. ASG, load balancer, and CloudWatch. I'm sorry about this one. They should have more decent, more deep question for ASG. When we go to the exam, trust me, there will be more deep dive question regarding ASG. Test your knowledge, test your understanding about like scaling policy, different type of them, and also like in situations where you have auto scaling thresh, meaning in a limited amount of time, you're seeing ASG keep adding new instances and terminate them, and keep adding new instances and terminate them immediately. Something like this one. What might be the root cause for something like this? Okay, so like I said, there will be deep dive questions regarding ASG. They won't be happy enough about just some features about some ASG. You want to dive deep and think about the use case. Okay, oh, nice. We have a question for this one. So I will give you guys like tens of seconds in locating the keywords for this question. So what's the keyword for this one? Anyone any ideas? Don't have to go to the answer yet. Just look at the question and finding me the keywords. Anyone? Cool. Thank you, Lisa. Thank you, Penis. So we have stack of traffic. Okay, we have stack of traffic, and we need to have 8 of them to handle the stack. And all others are happy with 2. So we also want to go with the cost-effective way, with the cheapest way in getting job done. Make sense? Thank you guys. You all found the keywords. Let's then look into all the option we have. First one says, let's create the ASG, meaning the capacity of 2. Sorry about that. Scale up based on CPU utilization. I will say when you have a stacks, like previous seconds, 2 is enough. Next second, I didn't have 8 of them. Can you adding another 6 instances in like 1 second? You definitely couldn't. So that's not fast enough. We can get rid of A. We can also get rid of B because like minimum capacity of 8 at all time will give me all the performance needed in peak time, but in other time where I only need 2 of them, is too much, right? So B is incorrect, over provisioned. And then C says you can have minimum of 2 and have a schedule to scale up to like 8 at 11:40. It look good to me because I have 2 needed million, and when needed before noontime, let's scale up to 8 because it takes time. So I say let's scale up at 11:40 rather than do it at 12. So I love C, but don't rush to answer. Remember, let's look at D. D looked to me quite similar like A, talking about minimum of 2 and scale up based on either CPU or RAMs. The thing is, with this question, it doesn't mention anything about whether your application is CPU bounded or RAM bounded. So I have no clue. It could be either A or D, but the thing is, it wouldn't be fast enough, so I can get rid of both of them. Correct answer will be option C. Hopefully, you all make a good choice. It makes sense, right? Thanks, David. Congratulations. And here's another one. It's just asking about characteristics about EC2 or ASG. Let's select 3 of them. Let's go through each of the options and see whether it's true or false. First one, A, send traffic to EC2. Is this something you do with ASG, or is it something you do with load balancer? So I will say, no, this is something done by load balancer. It's not the feature of ASG. I can get rid of A. Okay, how about B? Adding and terminating EC2 instance. Yes, that's something ASG will do for you. So B is correct. And C set collect and track metrics and set alarms. That's something done by CloudWatch Alarm. So not correct. Deliver push notifications. That's something done with a simple notification service, SNS. Launch instance from specific AMI. Yes, correct. And enforce minimum number of running EC2 instance. Yes, you can set a minimum number of EC2 in SG. Makes sense? Congratulations. Some key takeaway for this module. You can use caching specifically to improve performance. Remember, you can either use CloudFront and using last cache. If I'm using CloudFront, I can deliver both static and dynamic content. But how do I protect private content? Remember, talk about present URL and present cookie to enable access to private content in CloudFront, and also setting up OAI for your CloudFront distribution and put them into Azure Market Policy. That's how you protect your data in CloudFront. And for Elastic Cache, you need to know the difference between Memcached and Redis, and pro and cons of each, and make good choices when given a specific use case. Okay, and S3 is usually the choice whenever the data is unstructured, so that's the key takeaway. And when and why and how to use ASD, some key features about ASD is very important. And you also need to understand the key features about RDS and different database types, and including the databases not listed here, like DocumentDB, MO Neptune, etc., etc. Make sense? Cool. Does anyone have any questions? No? Okay. So, I think we can moving on. Change gear. Let's go to security. So before we talk about security, I'm just curious, does anyone have any questions at this stage? Give me a sec. Okay, I'm assuming no one have any question, so let's switch gear to talk about security. Okay. Hold on a minute. Got a question from one of students. Say, can we get this PPT slides? I'm sorry, we cannot. And like I said at the beginning of the session, this is a complimentary webinar. Therefore, no slides and no recording are going to be shared either pre or post this webinar. So sorry about this one. So yeah, hopefully that answers your question. If anything that particularly interests you, you can capture a screenshot during the session or putting some notes in place. Sorry about that. Okay, so domain 3, talk about security. This is a hard one because very often security is like very specialized kind of expertise. Now people very interested in security. I just gonna make a quick poll, say, hey guys, how many of you like super excited about security? You do security for a living. You cannot have enough of security. Security is so sexy. Anyone in the room? Give me your hands. Ooh, good for you, Gerard. Good for you, Panis. And I think that's only 2 of you among the audience who have a thing for security. Okay. For all the other people, probably not a thing, but it is very important if you want to get past the exams, because when it comes to cloud, we often say security is job 0, right? Okay, thank you guys for raising your hands. And so in this domain, we basically talk about 3 things. Okay, first one, how do you secure your application? Second one, how do you secure data? Thirdly, how do you secure infrastructure? Okay, basically from networking perspective. So that's the protection of your data, your application, and your infrastructure in different layers. Okay, so let's go to the first one, application layers. You need to know about this one. I'm making an assumption. A lot of you guys already seen this shared responsibility model for security. The thing is, when you come to the cloud, AWS is responsible for the security of the cloud, namely all those facilities, all the foundational services, monitoring and protecting networking traffic, etc., etc. And you as a customer are in charge of security in the cloud. Whenever you go to the EC instance, go into operating system, it's your responsibility of keeping them up to date with security patch. It's you who make a decision, what's the access control policy for my data set, where do I put my data, do I do encryption or not, etc., etc. It's also you who make a decision, how do I design my VPC, how do I design my subnet, do I want to open subnet to internet or not, what's my firewall rules, right? That's your responsibility. So whenever it come to OS, come to application level, come to access control, come to data, come to networking connection, that's your responsibility. And you should know what is IAM, Identity and Access Management Service. I cannot emphasize this more enough. IAM is very important for you to pass these exams. There will be very deep questions regarding IAM, like how do I create a least privileged access control policy using conditions like IP and MFA, and how do I do like federation with Active Directory service? The thing is, I don't want to set up my users in AWS IAM. How do I allow my user from my company logging through Active Directory, and then they can federally access to AWS console? How it is done? And very importantly, you should understand the use of IAM users and groups. Very importantly, you should understand what is IAM role and when do you want to use IAM role. Okay. So identity you can create in IAM, users and groups. That's relatively easy. Federally users authenticate in your Active Directory. Maybe some web federation with social identity provider like Amazon, Google, Facebook. That is enabled by using IAM roles. Okay, but what is this thing called IAM roles? The whole point about IAM roles is it enable you having temporary security AWS token and grant you restricted access to different AWS resource. So the grantee could be like IAM user, cross-account access, maybe some federation user from Active Directory, maybe some user from web identity provider. Once authenticated, they can take the token they get from web identity provider. They can come to IAM role. They can ask for exchange, say, this is my ID token, I'm already authenticated. And then you get a temporary token from AWS, allowing you to access some other resource like S3 and bucket. Okay, so the key thing here is using IAM role is preferred if you want to enable application, some service, talking to some resource in your AWS account. That's the key takeaway. I know it's gonna be a little bit harder for you guys if you are not in security kind of specialty, and that is why this white paper here is very important. We have a AWS security best practice white paper. In the white paper, it's talking through the details process, what the process look like, what's the best practice in protecting application at data layers, application layers, and also infrastructure layers, namely networking layers. Highly recommend. They also talk about some encryption stuff you need to know before you take the exams. Okay, and it is also recommended for you to go and search for IAM best practices because it gives you some best practice in using IAM. How do I protect my root account? How do I control least privilege access? And how do I enable MFA, etc., etc.? How do I use it IAM role? Okay, so highly recommend. And then we have a question. So what's the keyword for this one? Anyone want to give a try finding the keywords from this question? Okay, so thank you, Nisha. So we have the keys. That's the keys we want to protect. Okay. So when it comes to security, one of the things is you want to protect you like IAM credentials. Okay, compromise AWS credential like SSL security key is very dangerous, and this is about protect your IAM user keys. Okay, because you have an administrator who left the company. He used to be the root user, has a personal IAM account, and he created other IAM user keys, and then he leaves the company. Okay, what should we do in protecting the users? Some people already jump to the answers. That is quick. But let's go through each of the options and look at them. First one, change password and add MFA to the root. This is highly recommended. Okay. B says put IP restriction on root user logins. Can we even do that with root user? The fact about root user is it has unlimited access to all your resource and there's no restriction you can put up. So it's not feasible for you to put IP restriction on root user logins at this moment. So this is not supported currently. Rotate the keys and password for IAM users. That is something you want to do because think about this one. All the users and keys are created by this root user and he not leave the company. He might still keep the username and password for different users. So C is correct. And delete all IAM users. That seems to me a little bit too much, right? Delete all the users and create them again. That makes sense. I can just give them different keys, create a new password. That will do the job. Because if I delete all of them and create them again, I have to do all the policy stuff and give them security credentials. That'll be too much. So these overkill. Okay. And E says delete IAM user for administrator. Yeah, I will say this is something you should do. And F says let's relaunch all EC2 instances with new roles. The thing is, like I mentioned earlier, think about the nature of our IAM roles. When you have an IAM role, the key thing here is you get temporary AWS credential that allow you access to AWS. So meaning all EC2 with the roles, they don't have a strict credential. So you don't have to come in here and relaunch all roles with new all EC2 with new roles. That doesn't need it. So the correct answer is A and C and E. Make sense? Hopefully you all make the correct answer. Anyone have any question? Anyone disagree? Okay, let's moving on. Another question. Again, what's the keyword for this one? Application on EC2. Want to talk to LDB, the secure way in providing secure credential, right? So that will be the keywords. Okay, and then I think we talked about this one already. The key takeaway for this section will be IAM role is preferred in most use cases. So that give you a temporary credential, therefore you can worry nothing about losing them. So the correct answer will be option D, assign IAM role to EC2. Or the other ways, you hard code AWS credentials into your code and open source into GitHub maybe. That's a anti-pattern. Okay, so it is recommended using IAM roles and preferred. Let's switch gear and talking about another section. How do we secure data? So this is about encryption and also about access control. So when it comes to data encryption, if we talk about data in transit, there are different ways to get job done. You can think about, say, hey, when I got data into AWS infrastructure, I can use SSL. Okay, but if you're using SSL, you need to have application level support for SSL traffic, like HTTPS. Another option will be, how about we set up a IPsec VPN IPsec tunnel, and then you can use internal mode. You can use encryption to encrypt our data packet between different data centers and AWS VPC. You also have this option, say, let's set up a AWS Direct Connect and setting up a private fabric channel, connect your data center to AWS Cloud. That's another way to transfer data securely. Okay, if you are sending data to AWS APIs, like using AWS API calls, like put item, put object into S3 or DynamoDB, you don't have to worry because by default AWS SDK using HTTPS. Okay, and all the calls has to be signed using IAM SSH and secret key. So you have authentication and authorization done using IAM, and you have encryption by default. For data at rest, when you're putting data into Azure bucket, for example, we support server-side encryption. So you can also auditing the access across all your objects by enabling Azure access logs. And you also support resource-based policy. You can create a bucket policy that says whenever you put something into the prefix, you can only this group of people can access the prefix, access the folder under this condition, meaning the IP address has to come from this IP address, and you have to provide an MFA if you want to delete my data set, something like this one. This is about encryption. I think we mentioned this one already. You need to know server-side encryption in S3 with different options, say who provide a data key, either S3 or KMS or customer provided key, and what's the indication of that. You can also do some client-side encryption, meaning before I send data to S3, let's do encryption in client-side, and then send them to AWS. Okay, and in that case, you as a customer, you have to manage your data key that's going to be used for data encryption purpose at client-side. There are another level of complexity and of cost involved. And we have a service that can enable data encryption. It's called KMS, Key Management Service. It's a service that can help you to manage your data key using a two-tier kind of key hierarchy. First one is you create a master key in KMS. And secondly, you come to KMS and say, hey, give me a data key. I'm going to use that data key to do data encryption of my data set in my application. Okay, and I want to have my data key protected. And then when you ask for a data key from KMS, KMS is going to give you the data key generated by KMS. It will also give you a encrypted version of your data key that is encrypted, protected by the master key. Okay, so we're using a two-tier kind of key hierarchy, master key and the data key in protecting the data set. Okay, and then you only manage and control the number of master key. You don't have to manage millions of data key, which is very complex. So KMS has integration with many AWS services like data store and messaging, EBS, S3, DynamoDB, for example, SCS, SQS. They all support server-side encryption with KMS provided keys, something you should be aware of. And this is one example of using KMS. How do I enable server-side encryption for EBS? Okay, you need to know what the process look like. So this is the process. Firstly, you come to KMS, you create a master key. which is not shown on the slides. There is a master key created inside KMS that is solely used for protection of data key used by your EDS volumes. Say you have a master key already created. What's going to happen is whenever you create an EBS volume, that's step one. Whenever you create an EBS volume, say I want to have this EBS volume, servers are encrypted. What's going to happen is KMS is going to create a data key for the EBS volumes. It's a per volume data key, okay? It sends the data key in plain text back to your EC2, okay? And to make it even better, it sends back a encrypted version of your data key that is encrypted by the master key, also back to your EC2 and store them inside EBS, okay? And you keep that data key in plain text in the RAMs. Remember, any data key in plain text never ever reach disk, okay? Your application are going to use that data key. Sorry, your EC2 instance are going to use that data key to encrypt data and decrypt data anytime you read and write from EBS, okay? And here are the things, whenever you stop your EC2 instance or terminate EC2 instance, you lose the data key from the RAMs, but you still have a data key in encrypted version in EBS forms. So you launch your EC2 again, attach the EBS, it's gonna take the encrypted version of the data key and send them to KMS and asking for decryption. KMS using master key to decrypt your data key and get back to you. To keep them in the RAMs for all the future I/O operation go to EBS is using a decrypt version of data key to do the encryption and decryption. So that's the whole process will look like. It's probably the same process for all the other services. It's probably the same process if you want to enable application level data encryption and using KMS to provide a key. It's the same process. Makes sense? And we also have another service called Cloud SSM, which is another service you can use in managing and protecting your keys. Just be aware, Cloud SSM is a hardware security model dedicated to you as a customer. So it's a single tenant key management service. Okay, so that's the key difference between Cloud SSM and KMS. In the solution architects, associate level certs, knowing that should be more than enough. Okay, you don't have to dive into Cloud SSM. I should just know like the difference between Cloud SSM and KMS. When to use which one? Namely, Cloud SSM is a single tenant key, hardware security model in protecting keys. KMS is multi-tenant. Okay, so it's for compliance reasons. So compliance, when it comes to compliance, Cloud SSM support FIPS 142 level 3, and KMS support FIPS 142 also, but only at level 2. Okay, so about this. So you need to know the difference between those two. And also the ciphers, the encryption operation supported with Cloud SSM is symmetric and asymmetric encryption. Okay, and KMS previously only supports symmetric encryption. When I say previously, it means currently, surprise, KMS support asymmetric encryption now. Okay, which is a new feature that have been in the market for about a couple of 1 month, maybe a couple of weeks. So when you come to the exams, any new feature, any new service won't be in the exams until it's generally available for 6 months, which means KMS supporting asymmetric encryption won't be tested in the exam. So when you go to the exam, make an assumption say KMS doesn't support asymmetric encryption. You know that it already does. Okay. So high availability feature for your service Cloud SSM that's managed by customer in the sense that you have to specify how many nodes inside the Cloud SSM cluster you need to have. That's how you can have high availability. You can imagine I need to have at least 2 Cloud SSM nodes in one cluster to have high availability. And KMS, you don't have to worry nothing about it. It's already provided out of box. Okay. When it comes to pricing, you pay hourly fee for Cloud SSM. For KMS, it's pay per use. You pay by the number of API calls and number of keys managed by KMS. some other resource available, I will highly recommend you to read that white paper. We have a white paper called Encrypting Data at Rest white paper. And also we have a link that says Protecting Data Using Encryption in IAM S3. That is recommended. Okay. There's also a blog talking about a difference between IAM policy and bucket policy and ACL in control access to S3. Basically, it gives you more detailed information like I summarized previously. ACLs not recommended, bucket policy and IAM policy recommended, and difference between those two. Okay, we then have a question. So for this one, commonly use EBS volume to store critical confidential data. What's the keyword for this one, by the way? Anyone, any ideas? What's the keyword? So it's for encryption, right? Encryption is mandatory. Okay. So which service we can use? I think we talked about this one earlier. That's A, like KMS. Okay. So all the other option is not for EBS encryption purpose. And we don't have the content for networking security, but considering that we just have another long session, 1 hour and 10 minutes, might be a little bit too much. How about we just pause here and have a 10 minutes short break? So it's now 11:30. Let's have a 10 minutes break and coming back. Okay, short 10 minutes break and come back at 11:50. Okay, makes sense? So the thing is, we still haven't finished this model yet, but I wouldn't worry too much about this one because remember all the remaining 2 domains, they are relatively short. A section of this module talking about like protection of your infrastructure. Mainly we talk about security in the networking layers. It's mostly about VPC. Okay, so I'm assuming that most of you guys already know what VPC is. It's a private isolated network environment you can create in AWS Cloud. You can then further divide your VPC into different subnets, public subnet, private subnet, and VPN subnet. And when you create a public subnet, private subnet, and VPN subnet, you need to create different gateways, either internet gateways, virtual private gateways, or NAT gateways, to connect different subnet into different part of the world. And once you have gateway in place, you also need to have the routing table in place. Okay, so what I mean is, you need to really dive very deep into VPC, knowing about all the components you can create inside a VPC. What is an internet gateway? What is a private gateway? What is a NAT gateway? And what is a routing table? How do I make one subnet public? How do I make the other one private? How do I make the other one VPN subnet? Okay, and you also want to dive deep into the management of your IP address, private IP address and the public IP address, knowing the difference between EIP and the public IP address, something like this. Okay. So we don't have the luxury to go through the details for VPC, but basically you should know the difference between public subnet and private subnet is you have an internet gateway created and associated with a VPC, and you also define the routing table says if you want to go to internet, where should I go? I should go to the internet gateway. Okay, so basically everything in the public subnet can accept traffic from internet, where everything in private subnet is hidden from internet. They don't accept incoming traffic from internet. However, if you want to enable one direction communication from your private subnet, go to the public one, you can create a NAT gateway and NAT instance. Okay, and change your routing table with the private subnet says if you want to go to internet, you can send your data packet to the NAT service, and then in turn you go to internet and collect something back on your behalf. Okay, So you also need to know the difference between secret groups and a network ACL, network access control list. They are both firewall rules, but one of them are mandatory firewall rules, like secret groups. It is mandatory. Whenever you launch EC2 instance, you have to create a secret group and associate that secret groups with your EC2 or RDS. Okay, it's not an option. And also, it's a stateful firewall. You need to know the difference between stateful firewall and a stateless firewall. Network ACL is stateless. Secret group is stateful. Okay, and when it comes to evaluate the rules in your firewall rules, secret groups, all rules are evaluated together before deciding whether to allow traffic or deny them. And network ACL says, hey, let's give each rule a number. And when traffic coming here, the traffic will be evaluated against the number of the rules. And once they find the first matching, either allow deny, it will just be allow denied. You can have other rules, say, you can have 100 rules, 100 number rule says allow the traffic, and 200 allow rule says I want to deny the same traffic. The 200 deny traffic never even get a chance. Whenever you reach 100 and says allow, it will allow. Okay, so that's the difference between secret group and network ACLs, making sure you understand that and what's the indication of that. And this is the use of secret groups. You can put application servers and database into different type of secret groups and reference traffic coming from secret groups as a source for your data packet and allow them to go to the database. So making it very easy for you to set up firewall rules. And like I mentioned earlier, you want to know how do I connect my VPC into different parts, like to internet through internet gateway, to your on-premise environment through virtual private gateway. You can use direct connect, connect through virtual private gateway as well. And you should know like what is VPC peering, how VPC peering works, and what is NAT gateway, what's the difference between NAT gateway and NAT instance. Okay, so there will be a lot of questions regarding VPC and all the nasty details about VPC. So this is what it probably look like. On the left-hand side, we show you the NAT instance. On the right-hand side, we show the NAT gateway. Okay, so and then we have two subnets in each of the VPC. On the left-hand side, all your private instance in the private subnet talking to internet through that instance of yours. That instance is nothing but an EC2 instance living in the subnet in the VPC. That has a public IP address as well. You then have the routing table showing in the center here says, guys, if you want to go to the internet, the destination of your data packet is internet representing as 0.0.0.0/0 shown here. Where do I go? Where's my data packet? I go to NAT. Okay, that's what it is. And then you need to know the difference between NAT gateway and NAT instance. NAT instance is one EC2 instance set up as NAT, managed by you. High availability, scalability, and security, something you need to worry about. NAT gateway, on the other hand, is a fully managed gateway service offered by AWS. So high availability, scalability, and security is handled by AWS, making your life a lot easier. And I'm not sure whether you guys have been playing around VPC previously, but here are the things you definitely want to dive deep into VPC. We have a very good white paper called VPC Fundamental and Connectivity Options. It is highly recommended for you guys to come here and read the first white paper. And also you should know, like if I want to connect to my EC2 in the VPC, either SSH logging in or RDP logging in, you probably want to set up a Bastion host, which is nothing but a jump host. So what a Bastion host look like, how to set it up, what the architecture look like. So something you should know. So when it comes to VPC, you really need to know the ins and outs of VPC. If you have traffic from one place, want to go to a EC2 instance inside a VPC into a subnet, how do I enable communication? You need to have the route, you need to have the gateway, you need to have the IP address, you need to have the firewall, both secret group and the network ACL, allow that kind of traffic going in. Okay, so that's the thing with VPC. And then we have a question for that. Like I said, there will be a lot of questions regarding VPC. I'm going to give you guys a couple of seconds finding the keywords for this one and potentially find the answer. I'll give you guys 1.5 minutes for this one. So can anyone firstly tell me what's the keywords for this question? And let's look at this. Anyone have any question regarding the previous question? Regarding this one? Are we all good? Okay. If no question, let's changing gear to the second question. Like I said, going back, are we talking about this one or this one? So we have the second question. Like I said earlier, it's all about when we talk about VPC, you need to know the ins and outs of your VPC. This question say we have an EC instance set up as a web server. We try to connect to it using HTTP over internet. Couldn't get it done. So what might be the root cause for something like this one? How do I get it fixed? Okay, so the keywords will be like internet instance running a web server, couldn't connect to it. So how do we do troubleshooting? So anyone want to give it a try? So the things when it comes to connectivity, you want to first have because this is an instance running web servers, we want to enable connection from internet, except in this one. In that case, we need to have internet gateway. So A probably is correct. We need to have an internet gateway. We also need to have the routing table says if my data packet is 0.0.0.0 something representing internet, where do I go? I go to internet gateway. So A is correct. I hope you all agree with me. And B is not relevant because B is talking about virtual private gateway. Virtual private gateway request originally from virtual private gateway have requests coming from internet, but it's mainly about connecting VPC to an on-premise environment. It's not about serving some web servers, so it's not relevant. And then it's about firewall rules. Remember, we have 2 firewall rules, so therefore you need to have secret groups allow inbound traffic. That's for C. And you also need to have ACLs allow inbound traffic on port 80 as well. Okay. I will say, so those are the correct answers. Hopefully you all get the correct answer. But I will say, it's not a perfect answer because if you say I want to using network ACL allowing inbound traffic on port 80, you also want to set allow rules for outbound traffic on network ACL because that's a stateless firewall rules. I'll be happy with this question because it says you need to select 3 correct answers. But if you go to professional one, you definitely need to know say there need to be a outbound allow traffic as well on dynamic port number. Okay, so some key takeaway for this module will be like you need to know how do I follow the best practice in protecting my IAM credentials. There's a best practice page for IAM, and using IAM role is almost always preferred over other kind of state credential configurations. Knowing the difference between secret groups and network ACLs. And another very important facts for you guys to remember, secret group is always whitelist. It can only allow something to happen. And network ACLs can be either a whitelist or a blacklist. So you can allow or deny certain traffic. That's the key takeaway for this module. So before we moving on to the next one, anyone have any questions? So look like we are all good. No questions? Okay, so let's come to domain 4. Domain 4 is about saving money. Okay, so when I build my application in the cloud, how do I make sure I can save money, making cost awareness decisions? So this is about understand the pricing for storage and compute. So of course we have all the different services. It wouldn't be feasible for the understanding all the different kind of pricing for 100-something different services. In this exam, we're going to focus on the pricing for storage and pricing for compute. So remember the pricing model for AWS is the basic principle will be you pay as you go, you don't have to pay any upfront fee. And you pay less when you reserve. So we have, for some resource, we have some reserve pricing, like for EC2, for RDS, for Redshift. Even for DynamoDB, you have this ability to pay for some reserved kind of capacity, and you then get some discounts. And for some other services like CloudFront, S3, data transfer to internet, you get some volume discount, meaning the more usage you have, the deeper the discount will be. Okay, that's the basic principle. And when it comes to pricing for your use of some basic AWS services, it's all about the pricing for compute, storage, and also data transfer to internet. Okay, so the first one, how do we determine cost optimized storage? It's all about S3. So you need to know how you pay for S3. You actually pay for different things. First one, storage capacity, and secondly, number of API requests. Be aware that you are paying, like for every 1,000 API requests go to S3, there are certain costs involved. And also, whenever you want to transfer data from S3 to internet, when I say internet, it means that whenever I want to send data from S3 to literally an end user from internet, or maybe data from S3 to other EC2 instance in another region, that can be considered as data transfer to internet. You pay for data transfer cost, and then be aware choosing the right storage class can save you cost. So this is different costs regarding standard storage, standard infrequent access, and Glacier. Again, we don't have to remember the number here, how much money you're going to pay for different storage class. But the thing is, you should know we have different storage class and there are cost considerations when making the choice. And also, in the associate level exam, you're going to be tested against like the pricing for EBS. Okay, when you use EBS, you pay for the type of volume, either HDD or SSD. You also pay for the LPS provision. Say, if you're using provisioned LPS EBS volumes, you pay for the LPS provision. For all the other type of EBS volumes, you pay for the number of I/O operations. Okay, and then thirdly, you pay for the snapshot storage capacity. As a backup for EBS volume, you might create multiple snapshots. The more snapshots you create, the more expensive it's going to be because you pay for storage capacity. Okay, of course, at the end of the day, you pay for storage capacity. Okay, and how do I optimize cost? So eliminate any potential waste you might have with EBS. That means if you have any EBS volumes not needed, not attached to any EC2, probably you can create a snapshot and delete that one. Okay, so delete any untouched EBS volumes, but definitely create a snapshot if you want to keep the data later. And if you find the EBS volume is underutilized, either from capacity perspective or performance perspective, you provision a lot of IPS but not using them, and you want to resize capacity or maybe change the volumes type, Also, delete any still EBS snapshots. You might very easily create a lot of tens or even hundreds of EBS snapshots. But according to your backup policy, you only want to keep backup for the past 1 month. Then deleting all the previous EBS snapshot can save you a lot of money. Okay, and we then have a question for this one. It's about choices of storage from cost perspective. Okay, so let's read the question. Can anyone give me the keywords for this question? What's the keywords for this question? Anyone want to give it a try? So, thank you, Nisha. So we mentioned publicly available, okay, and millions of time download. That's very important. And it also mentioned about most cost effective. So whenever you see this one has to be publicly available from internet, millions of time access, you probably think about, hey, we wouldn't be able to get it done with Glacier and EFS. So we can get rid of EFS and Glacier very quickly. And then it has to be a choice between A and B. Okay, A says S3 standard and B says S3 standard infrequent access. Remember I talked about this one previously. They are roughly the same thing, but except with different pricing structure. S3 standard charge you a little bit more for storage capacity, a little bit less for getting access to the dataset, versus S3 standard infrequent access, charging a little bit less for storage capacity, but maybe a little bit more for getting the data out. So we are talking about millions of downloaded by customers for the same object. Apparently, the good answer will be A, right? Congratulations. And that's the pricing for S3 and EC2. And also, you need to recognize other opportunity to further reduce cost for compute and storage using serverless compute and storage services from AWS, like Lambda function. If you find yourself running some simple application running on an EC2 instance, a lot of time it's sitting there idle, probably I can put them into Lambda function. I only pay for the number of invocations of my Lambda function. And if I have data into like some content, web content, put them into S3 might help you to reduce cost because you don't have to put them into EBS. And DownDB, a lot cheaper for a no-zero damage offerings. And you can also use CloudFront to reduce the cost of data transfer to internet, because data transfer from CloudFront go to internet. You can enjoy deeper like volume discounts. Okay, you're going to pay for the number of data transfer to internet and also number of requests. And for the compute, reduce number cost for compute is all about knowing the type of price options we have. But this is a short list in considering how to reduce cost for use of EC2. First one will be like clock time. So when you use EC2, it's always pay-per-use. So if you have EC2 up and running, doesn't do anything, you might as well just terminate or stop the EC2 instance to reduce the cost. And secondly, you want to right-size instance types. Choose the right instance family according to application, and then choose the instance type that can reduce the cost. And number 3 is very important. Choose the right pricing option. Knowing the difference between on-demand, reserved, and spot instance and dedicated, and make good choices can save a lot of money. There will be a lot of questions in the exam says, hey, we want to run this batch processing, we want to run this reporting. It's like you can survive some interruption at the end of the day as long as you can make job happen. In our case, very often it's asking about using our spot instances, because using spot can save you a huge amount of money for any kind of batch processing workload. Okay, and you can also change the number of ECP instances to reduce cost. When you have too many of them, you can use ASG to terminate each instance when there is less traffic. That means you can save money, right? Tenancy, making sure that you're using on-demand multi-tenancy in most of the time. You're only using dedicated single-tenant instance when you have no other choices. Detailed monitoring, okay? If you enable detailed monitoring, that's additional cost. By default, is basic monitoring for EC2. You get data metrics every 5 minutes. If that's not fast enough, you can change to detailed monitoring. You then can get performance metrics, visibility at 1 minute interval. I mentioned this one already. ASG can help you to reduce cost, and some other license fee you need to think about. Okay, so you need to know what is reserved instance, what is spot instance, and with reserved instance, there is a standard reserved instance, convertible reserved instance, and scheduled reserved instance. You have to know the difference between different type of reserved instance. And here's a question. So it's a little bit interesting. Can anyone find me the keywords for this question? Anyone want to give it a try? What's the keywords? Someone raised their hands. So if you want to participate, just put into the question panel, Saxnisha, so the batch job, and 90 minutes. I think anyone find any other keywords in this one? Go to answer already. Okay. That's big, but here are the things, the keywords actually, there's another one. Cannot be postponed. I think this is very important one. So you have this workload happen every Sunday night, complete in less than 90 minutes, and cannot be postponed. So you cannot go with spot, because if you go with spot, if you're not willing to pay the max money higher than the marketing price, you lose the instance. So spot instance wouldn't do the job because it cannot be postponed. Okay, and in that case, it will be C, scheduled instance, that will allow you to reserve instance, but not reserve for the whole year, but reserve for the reoccurrence of that workload. So C is the correct one. So apparently you need to know what is scheduled instance in the first place, right? Some key considerations from this module, okay? Reserve can save a lot of money, and knowing when to use spot instance. If your application can survive interruption, spot instance is always a good choice. And monitor the utilization of CPU and making sure you reduce the size of instance and consolidate workload and maybe stop them when it's not used. And then also you need to know, like, how do I make best use of storage by like leveraging all the storage pricing of S3 or AWS. Okay, so we then come to the last module of the day. This is about operational excellence. Okay, so like I said, this is an architecting exam. It doesn't require to have very hands-on experiences, but as a solution architect, we do need to have a certain level of hands-on capability in providing some technical guidance at the early stage of the project. Okay, so you want to design an architecture that is easier to operate in a cloud environment. So it's all about how do we prepare the environment, how do we operate them, how do we keep changing the architecture. The things, remember I said about earlier, this exam is designed after the AWS Wheel Architecture Framework. So we have a white paper solely for operational excellence pillar. So I will highly recommend you to look into that white paper to get more in-depth content. And there are different services regarding like operation, but because there is only 6% of scores goes to this domain, there are many services being tested in the exams. So I list some major services in here. Namely, you need to know what is cloud formation. I mentioned this one already, and some other service that can help you to have better visibility into workload. that will be like VPC flow logs and also CloudTrail. Okay, API recording service of CloudTrail and having visibility into all the traffic going on into VPC. That's the VPC flow logs. Okay, we have another service called Trusted Advisor, which is a pretty good one. It's a recommendation engine. Based on your account usage, it will make a recommendations as, hey, probably you can make it more secure by changing configuration of your firewall rules. Probably you can make it more highly resilient by deploy application across market easy and using advanced load balancer. Something like this one. So it make a recommendation for security, performance, high availability, and cost optimization. That's what we can get from Trusted Advisor. And also AWS config. I think I mentioned this one already. It's a configuration. You can think of this one as a lightweight configuration management kind of database that will give you the track of all the AWS resources you created in the account and what's the configuration for that resource. Okay, so what I'm trying to say is, and also I am an inspector. This is a security assessment service, which is also an agent-based service. It runs some security analysis, security assessment inside of EC2, okay, to find some security vulnerabilities, etc., etc. So what I'm trying to say is, for the operational pillar, for the operation excellence domain, you don't have to go too deep. Okay, for those services listed here, you need to know what those services are and what problem you can solve with those services. Okay, but with CloudWatch, you need to dive a little bit deep. You need to know like what metrics are, how to create alarm based on metrics, how do I create my own custom metrics using CloudWatch. Okay, you also need to know like what type of built-in metrics you can get from CloudWatch without you doing anything. Like for EC2, what's the metric you can get? For example, CPU, networking I/O, and storage I/O, and also healthy status. For load balancer, what type of metric can you get from load balancer, etc., etc. And you then need to know how do I create an alarm based on metrics, and what kind of action can I trigger using alarms. You can trigger notification using SNS. You can trigger auto scaling to scaling out. You can also terminate, reboot, or auto recover your instance using CloudWatch alarms. Okay. So, like I said, for operational one, dive deep into CloudWatch and knowing the use case for different service, that should do the job. And then we have a question here. Can anyone find me the keywords for this one? What's the keywords for this question? Anyone want to give it a try? Obviously, this is about CloudWatch metrics and alarms. So how alarm being created and when the alarm will be triggered. Okay, so what's the keyword for this one? So this is how I define my alarm. I define my alarm as the metric should be higher than certain threshold and over a period of time. So in this case, it says alarm will be triggered over 3 periods, each period of 5 minutes. Okay, so we then see the metrics as we have the metrics going up to 80%. That's higher than threshold, but only that's been up to 80% for 10 minutes. That's 2 periods of 5 minutes. It won't be enough to trigger alarm because alarm says it had to be higher than 70% over 3 periods. That is 50 minutes. So in that case, how many alarm will you receive? None of them. Okay, so this is about understanding the nature of CloudWatch alarm. So congratulations, guys, you get a correct answer for this one. Okay, congratulations, and hopefully we all agree this is the correct answer. So anyone have any question? How about another one? what's the keyword for this one then? We want to track for errors in the Apache logs. Okay, how do we make it happen? So the keywords might be, the keyword will be, we want to track number of 44 by collecting the logs. Okay, so that's keywords. So we now have different options. Can we get that done with VPC flow logs? Can we see application level metrics from VPC flow logs? So how many people have actually looked into VPC flow logs? When you go there, you didn't see any application level kind of information. You only talk about, hey, we have this data traffic coming from this source IP address, go to this destination IP address, and what port number, whether it's accepted or rejected, and how much data being transferred. Okay, so that's where you go from the flow logs. You don't get to see like what application it is and what's inside the application, whether it's 404. So A is incorrect. B says metrics. Metric is about performance metric or result utilization. You don't get 404 errors, right? And option D says web application running on AWS never have 404. I would love to have that something like true, but the thing is, 404 is concept error says object does not exist, right? Or no permission, so it can have 404, depends on configuration and depends on your web content. That leaves the only possible correct answer, which is option C. You can use CloudWatch logs to get web server. Okay, logs from EC2. And then you can create a magic filter out of the CloudWatch logs to counting how many occurrences of 404 errors in the logs. So you can turn the log entries into CloudWatch metrics, and then you can create alarm to trigger notification. So the correct answer will be option C. Hopefully you all agree with me. We have the last question for this one. And this would probably look a little bit familiar to you guys. Remember previously we have a question that says, hey, I think that's in security domain. It says you have Python code running on EC2, which need to talk to DB. Okay, what's the most secure way in providing secret credential? I think with that question, we go with IAM roles. Okay, in this case, it changed it a little bit. So you have application on EC2, this time you want to talk to bucket. So how do we give application access to bucket? Securely. It's about secret credential, right? So should I put them into EC2 instance in the file called secrets? And that's hardcode secrets, probably not so secure. And attach IAM role grant permission. Like I said previously, when it comes to SHA key, IAM role almost is always preferred. So B might be the correct answer. But don't rush. Let's look at option C. Put them into this credential file. Again, the same thing is hard code, it's static. Secret credential is not secure. So now this one, open bucket to public. That will be too much. You do not want to do that. That's the last thing you want to do. So D is incorrect. So the correct answer will be option B. Make sense? Okay. The key takeaway from this one, you need to know from CloudWatch what kind of insight you can get from CloudWatch, like the beauty metrics you can get from CloudWatch for EC2, for load balancer, for RDS. And when do you want to create a custom metrics? Okay. Also, you want to say, hey, when will trigger a CloudWatch alarm? You want to understand the detailed definition of CloudWatch alarm and when it will be triggered. Okay. And IAM role easier and safer than keys and passwords. It is always preferred. That's about everything. Like I said earlier, this webinar will point you guys to the right direction. So when we go to the exam, you should know like what kind of domain knowledge you should already have before you go to the exam.